Good morning, everyone. We have, as of yesterday, we had more than 100 people signed up, but you can see that our attendance has dropped off significantly. But we're going to go ahead and we will produce a report that will try to capture the essence of this meeting and get it widely distributed. Today, I'm Jerry Schubels, in case you don't know me, president of the Aquarium, and today is another in the series of conversations that we're having looking at the issues of sea level rise and coastal flooding in Long Beach's most vulnerable areas. And today we're going to look at it through the eyes of a leading coastal scientist and a leading coastal engineer. Previously, we've looked at it through the eyes of a geologist, through designers from the Art Center College of Design. We've looked at it through some policymakers. So today is different. And I think those of you who are here, I appreciate your being here very much. You know, the coronavirus is obviously taking a toll on people going to meetings, and it's going to play out over months to the order, I think, of a year. Stock market collapse is very disturbing. That's probably going to take years, in the order of a decade, to recover from where it is. Sea level rise and coastal flooding, that's decades to centuries. And there are things that we can do to buy time to deal with this in a more thoughtful, measured, scientific way of how we can cope with sea level rise and particularly with coastal flooding. And we need to have these ongoing conversations based in science, and not just the physical and natural sciences, but the social sciences, and not just economics, but sociology, psychology, and so on. We don't want to see a repeat of what happened in Del Mar or in Imperial Beach. So we will continue to have these discussions, and we will continue to bring different perspectives to view, and we will hope that we will get very active participation by members of the city. So I would like to, first of all, show you my desires for what I would like to see us accomplish. I would like to, by the end of this session, have a clearer understanding of the existing threat from coastal flooding in the most vulnerable areas of Long Beach. I'd like to have a better understanding of the prospective threats of coastal flooding over the next few decades, the relationship to sea level rise, and of how those threats will be manifested. Are we going to be in for something like Sandy on the East Coast, or will it be quite different here in California? I'd like to have a clearer understanding of how these threats can be mitigated through appropriate actions, at least over the next few decades. And what are the longer-term prospects for sea level rise and coastal flooding, and what are the implications for residents of the most vulnerable areas of Long Beach? So we want to get the best scientific and engineering knowledge brought to this, and I hope we can bring a great sense of candor. Now, Alyssa Mann is my counterpart at the Nature Conservancy, and as you know, this project is a joint venture of the Aquarium of the Pacific excuse me, and the Nature Conservancy. Alyssa, there's Alyssa.
Thank you, Jerry. Again, my name is Alyssa Mann, and I represent the Nature Conservancy here in California. Thank you to Dr. Schubel and the whole team at the Aquarium of the Pacific for hosting today's event, and for your leadership in convening this series of seminars and listening sessions about potential sea level rise impacts here, and starting a community dialogue about what the vision might look like for addressing these challenges. As you'll hear from the keynote speakers today, while we don't know when different sea level rise scenarios may impact our coastline, resulting in frequent and extreme flooding events, as well as permanent inundation in some areas, we do know that these changes are coming. We also know that we have some time to make smart and sustainable decisions to adapt, to minimize harm to those affected, and preserve these amazing coastal resources. As you've likely heard from Jerry and from me, if you've been participating in any of these convenings to date, the purpose of these seminars and dialogues is to hear and understand your concerns and your hopes for the future of Long Beach and Alamedas Bay, and your perspectives on options for adapting. These are wicked problems, and as Albert Einstein advised, we can't use the same thinking as before to solve them. To help spark this conversation and get us all to think outside the box, we've been inviting innovative thinkers, experts, and scientists from a variety of disciplines to share their perspectives about this issue and innovative approaches to solve it. Today, we're talking about engineering solutions. We've also heard from designers and oceanographers. We will also be hearing from students from CSU Long Beach MBA program on the financial implications at risk. But there's still a lot of work to do, and we are just at the beginning of this conversation. We need to not only think about what we can do in the near term, but also think about how the choices we make today will impact decisions available 30 to 40 years from now. We need to better understand what are the potential barriers to action in Long Beach, what are the opportunities to act, and what are the likely compromises and trade-offs. We need to also think about how important this coast is for the whole region and how to make future action more equitable and inclusive. We need to think about how outreach will look like in the next 1 to 5 years. Would it be better or worse to talk about these issues again after a flooding event? Who would lead that effort? We also need to keep advocating for support and policies at the state and federal level to help implement Long Beach's vision. And as uncomfortable as it is, we also need to begin to talk about the point at which moving out of harm's way may be the best choice from a health, safety, economic, and environmental standpoint. And what are the strategies to facilitate relocation that minimizes harm? The alternative is unmanaged retreat in the form of destructive flooding and inundation. And we have the opportunity here to plan ahead and turn this challenge into an opportunity. So what are we trying to achieve today? We are likely not going to find, quote, the answer. What we're going to do today is talk about the range of options and hopefully identify areas and concepts we want to investigate further in this particular geography. After Drs. Flick and Crampton, you're also going to hear from Dr. Giuliano Khalil, founder of Virtual Planet Technologies, about the Sea Level Rise Virtual Reality Explorer we are developing as a part of this project. The purpose of the VR is not to scare people, but to create realistic understanding of the issue and to show solutions of what might be possible. You'll have the opportunity to preview the VR experience following this event, which shows different scenarios, including a major storm today, and a few different sea level rise scenarios. The solutions will be developed given input that you all provide today. And so we'll be developing those over the next few months, depending on the outcome of today's meeting. We plan to show conceptual renderings of both near-term and long-term options. We really look forward to hearing your thoughts and input today, and thank you for being here.
Thank you, Alyssa. And our first speaker, Dr. Reinhard Flick, Ron Flick. We've known each other for more than 40 years. No. And over that time, I've worked with a lot of coastal oceanographers, but none for whom I have greater respect for his knowledge, his willingness to apply that knowledge to solving practical problems, and also to advancing our understanding of coastal processes. So please join me in welcoming Reinhard Flick.
You can't do that anymore. Well, thank you, Jerry. I feel awkward, especially with this kind of an introduction. And I felt awkward in Texas once about 25 years ago. I was working on a very high-profile boundary case for an 800,000-acre ranch, one of the largest private land holdings in the country, controlled by the Catholic Church, in the suit against the state of Texas, immovable object and irresistible force. So I was curious, what in Texas, what was the qualifications for an expert, to be an expert? And the lawyer at the time, the head lawyer who was 25 years ago charging $600 an hour, He said, it's real simple. It's a guy from out of town with a briefcase. So hopefully the standards in Long Beach aren't any higher. So thanks for coming. Thanks for braving the virus. Walter and I promise to be just as infectious. So what are we going to talk about? Who was here for my talk in late January? One person. Great. Oh, Jerry. Yeah. Great. 3 people. Okay. Well, in January, I covered a lot of ground with those white subjects. I'm going to review some of that, but I want to focus on, in this session, I want to focus on the yellow parts. So if you'll just read those while I talk, we'll give you a few seconds to read those. It's to begin a conversation, as Jerry and Alyssa said. I think Alyssa framed the subject very, very well. To start a conversation about how this is all going to play out over the next decades. Some of us only have a few decades. Of course, Jerry's been around since the last ice age, and he'll probably be here till the next one. But most of us baby boomers are going to be gone. And this is the really sad part. I've worked on sea level for 30 years now, over 30 years, and I'm not going to live to see the worst of it toward the end of the century, and that really makes me sad. Anyway, if you're engaged in this the way I am, the worst of it is not going to happen unless something unusual and very frightening happens very quickly in West Antarctica. The worst of this is not going to manifest until mid to late century. So we'll talk a little bit about the probabilities about all of that. So this is not fake news. This is long established science. I've got a picture here on the left. Oh man. A picture here on the left of John Tyndall. He was a chemist that worked in the mid-1800s. He published papers around the time of the Civil War. He was the first one to measure the radiative properties of CO2 and many other gases, to physics, describe the physics and the quantitative physics of the greenhouse effect, essentially. By the late 1800s, a guy named Svante Arrhenius, who was a chemist, Nobel Prize-winning chemist, and actually the grandfather of a chemist that worked at Scripps Institution of Oceanography, where I am, talked about the quantitative amount of warming. So 8 degrees, he guessed, if 2 or 3 times the CO2 at the time when CO2 in the atmosphere was 295 parts per million. There's a 1912 news article that talks about the 7 billion tons of carbon that is pumped into the atmosphere from fuel every year, and this is in 1912. And the bottom line, you'll see it says the effect may be considerable in a few centuries, and they had that right. So all of this is old news. It's well-established science. There's very little debate about the fundamentals of all of this, the physics of global warming, how it happens, and why it's going on. So there's a really cool quote from Neil deGrasse Tyson, "Science true whether you believe it or not." So the bottom line here is, please believe the science. Let's at least start with with common facts and common knowledge. All right. So a little bit of perspective here. Walter especially, and most other people get nervous when I start talking about geology, but I will anyway. So here's the ice core data for temperature and carbon dioxide, right? Because carbon dioxide gets stuck in ice. When it freezes, it gets buried over the next year, right? And so you can have 800,000, this is from Antarctica, you can have 800,000 years of ice build up in the 2-mile thick ice sheet in Antarctica, and you drill through that and you can capture the little bubbles and measure the gas inside there. And what you see is the bottom graph. You can see temperature and you can see CO2 over the last 800,000 years. CO2 was a maximum pre-industrial age, about 280 parts per million. And the temperature fluctuations compared to the 1950 or so average is on the left here, the 0. It was never much warmer. except during the Eemian time, 120,000 years ago. And pay attention to these numbers, right? So 3 degrees warmer and sea level was 20 to 30 feet higher. 2 or 3 degrees centigrade warmer. The Paris Accords, right, that we pulled out of recently, the Paris Accords, they wouldn't work anyway. But if they had, they would try to limit emissions and limit the temperature rise over the next century to 2 degrees centigrade. We are already at 1 degree, so if you look at the upper graph there on the right, you can see from pre-industrial times, we are about 1 degree centigrade warmer than we were, and CO2 concentrations are well on the way to doubling. So we're at 413 parts per million now, well on the way to 560 parts per million, and that's almost unstoppable from what you'll see in a few slides. So I have these little keynote things that I'll summarize at the end in a couple hours. We should cut carbon emissions. We should. This is the mitigation part. We should mitigate to try to limit the amount of greenhouse gas emissions and limit the ultimate warming that will occur over the next couple of centuries to where we don't end up with a Venus effect, you know, where it's 700 degrees and the carbon dioxide concentration is 90% in the atmosphere instead of 0.04%. Okay. So now sea level rise is sharpening and making more acute and challenging the challenges and the trade-offs that we have faced in the California coast and most other coasts, of course, but specific to California, that we faced all along ever since development started in California 150 years ago. And the 3 major challenges and trade-offs are, first of all, the balance of competing interests, right? Commercial, institutional, they're listed there, versus sand supply, versus armoring. So the competing challenges, the competing needs of a developed and a developing society. Secondly, beach width. First thing that comes to people's minds when you say California is the beaches and the Sierras, right? Those are the 2 important things. Well, if it's my wife, then it's the wine. Okay, me too. But the beaches are important. They're critical to the culture, to the economy, and to everything else in California. So that's the second thing. How do you keep enough beach width in view of all these other pressures? And then thirdly, and I think as importantly, preserving the natural features, the access and the resources, including surfing, fishing, wetlands, what's left of them, open space. And this is especially a challenge in Southern California and has been for a long time. So the fact that sea level rise is accelerating, sea level rise has been going on for 20,000 years, but just not as fast as it's expected to accelerate to in the next decades and centuries. So I think this kind of frames at least part of the challenge that we face. Now, I didn't get a chance to show this in the last time I was here to talk, but the geological setting of where we are is extremely important. In fact, it's probably the most important single factor that determines the future, determines the setting of the coast, the past and present, and also the future. So what you'll see here is that we are on the Pacific Ring of Fire, right? The San Andreas Fault System is the border. It forms the border between the North America Plate and the Pacific Plate. I have a stair right here, right? So that whole San Andreas Fault System is our local part of the Pacific Plate, which is grinding up against the North America Plate and moving north relative to the North America Plate. And you'll see that on the right side. Those little arrows indicate the relative motion of these 2 plates. And this is not very fast, right? I mean, you can't get on this and be in San Francisco in a couple hours. It's more like you can be in San Francisco in 100 million years or something like that. But the importance to our discussion and to any discussion of the California coast, of why it's so beautiful, for example, is the fact that The fault system, this part of the San Andreas, it's called the Newport-Inglewood-Rose Canyon Fault, the one that goes along the coast, all the way from San Diego up past Long Beach, is sinuous. It's not straight, it's sinuous. It's S-shaped. It's got curves in it. And so what happens when you have this motion, this northward motion relative to the North America plate, is that pieces of this fault bump together and other pieces separate. And so what that leads to is when they bump together, something's got to go up, okay? And when they separate, something's going to go down. And so what we see is this alternating, and it extends all the way up the California coast, at least to San Francisco, are these features of alternating highs and lows, river valleys, lagoons, and then headlands. And so I've got this shot of Palos Verdes there looking south, Long Beach in the right corner there on the right side. And so most of our coastline is actually relatively immune, or at least less threatened by sea level rise than many other coasts, right? Think of the Gulf Coast, the East Coast, for example, are much more low-lying, much more subject to severe weather, hurricanes, and all of these things that we don't have. And the reason for that is the tectonics. So when people tell you that, you know, I had a vacation in California, it was very uplifting, that's actually literally true. Okay, now where are we? I'm getting old, so I have to remind myself where we are. We are in Long Beach, and you'll see on the upper right, we're talking mainly today and focusing our attention on Belmont Shore, the Long Beach Peninsula, and Naples, the low-lying, most vulnerable areas that Jerry hinted at. And one of the key features here that makes Belmont Shore and Peninsula and Long Beach in general different than most of, almost all of the rest of the open coast of California is this nice little feature, nice little feature you have here, courtesy of the Corps of Engineers. Okay, I was promised I could go backwards. There we go. Okay, and that's the LA Long Beach outer breakwater, and with its two entrances for shipping. And that's been there, what, since the 40s, maybe 30s? When was it built? 40s. And what it does, in effect, is shelter most of Long Beach except for parts of the tip of the peninsula from the waves from the North Pacific Ocean. And that's a big deal. So here's a thing you can get on the web on the left there. This is a Storm Surf website, Storm Surf forecast for Saturday. And what you see is interesting. The offshore wave heights are 8 or 9 feet out here in the yellow. But the wave heights inside at Long Beach, just south of the Palos Verdes and toward the harbor area there, are a foot or even less. And so there's a high sheltering, partly would be anyway just because of Palos Verdes Peninsula, but for almost all directions except from the south, this area is highly sheltered from waves. And that makes it unusual and much more manageable than most of the rest of the open coast of California. Now there is this window, and it became clear from Hurricane Sergio back in 2018. This is a coastal data information program, a SCRIPS program funded by the state and the Corps of Engineers, and it shows the Northwest Pacific swell coming in here, and then even higher, you'll see the wave heights over here, what is it, 4.5 feet or so, coming from almost due south, 270 degrees. Is that better when I talk louder? I can't, I'm too tall. All right. And that created havoc at least the southern tip of the peninsula. You'll know better than I do because you were here, right, many of you, of the problems and the flooding that caused. So there is an opening to the south where the peninsula and Belmont Shore and, of course, Seal Beach and the rest of it are more vulnerable. And so as the Pacific warms, as more hurricane activity is fueled off the coast of Mexico, and as these things come farther north, this could become an increasing problem in the future. Now, in 1939, right, before anybody was really talking about sea level rise or warming in a serious way, there was a hurricane that did make landfall in Long Beach, killed a bunch of people, and did a bunch of property damage. So this is not impossible. It's not out of the question that we'll have southern exposure here that's serious. What's shocking to me is that there's no wave gauges inside the breakwater, at least not any long-term wave gauges or long-term measurements, or any real long-term wave studies of the kind that we had. So this CDIP, this CDIP work, this has had now at least 2 PhD theses over the last 30 years to develop this wave model. It's the basis for most of the commercial surfing forecasts, right? That was developed first by Bill O'Reilly and others in the 80s, and then currently from a recent graduate just 2 years ago. So not having much more detailed wave information inside, just out in front of Long Beach, inside the breakwater, is a little disappointing and a little bit surprising. So that's something I would suggest that get done. Okay, now, what kind of future do we want? Well, I love quotes. You'll see that in the next few slides also. So this was Greta Thunberg, right, from Sweden. I want you to panic. I want you to act as if the house is on fire, because it is. And she's talking about the warming in general. So the question here is, and the reason I frame it this way on the right, is because the latest guidance, I put guidance in quotes, from the California Coastal Commission and the Ocean Protection Council. And guidance in this sense means you damn well better take this into account if you want a permit. That's the guidance. That's what guidance means in state jargon. There are 2 possible futures considered in what I'll talk about shortly. There's a high emissions, and those of you that follow the IPCC, it's the so-called 8.5 radiative something, radiative, what's it called, radiative concentration profile or something. Anyway, it's the number of watts per square meter excess radiation that will occur by 2100 if we go in the high emission scenario. So it'll be 8.5 watts per square meter global average of excess radiation to warm us, keep us toasty. And that's the trajectory we're on now. So you see now is 2020. And then there's a low emissions scenario, so they just break it up into 2 rather than the more complex, 4 or 5 more in between. A low emissions scenario, which imagines that we'll do something very quickly about limiting carbon dioxide, limiting greenhouse gases, and those will peak and maximize in 2050 or so, and then drop precipitously to net zero and below, and actually go negative, so that the worst effects of temperature rise are avoided. Well, like I said, right now we're on the high trajectory. Things like recessions caused by viruses or by housing crashes, like the last recession, tend to slow the greenhouse gas. So there's a little bit of a silver lining to some of these depressions, although I don't recommend it for your 401. So there you can see the 7 gigatons that during the late 1800s. When the work earlier I showed, we're now at approaching 35 or 40 gigatons per year. So the question is, what future do we want? And that's really the largest uncertainty. We're going to have some discussion about uncertainty. The biggest uncertainty is what humans are going to do about emissions. That's the biggest uncertainty. It's not the science as such. Now, we don't understand, if we have a doubling of CO2, we don't know exactly if that's going to be 2 degrees or 2.5 or 3. That's true. So the science is uncertain in that regard. But the biggest uncertainty of all is nobody knows what humans will do in the next decades or century to limit the effects. All right, so this is Jim Hansen 32 years ago, one of the leading climate scientists in the world. Ironically, he started his scientific career studying Venus. And this got him interested in CO2. And he was one of the early, said, look, if we keep this up, we're going to have a runaway Venus effect on Earth. And, instead of an average temperature of 60 degrees, it'll be 600. That's far-fetched. That's, not likely in the next few hundred years or even few thousand. But that's probably how Venus got started as well. Anyway, we need a steadily increasing carbon fee. So that was his method, and still may be the most economically rational way to do it. Just price carbon to pay all the externalities, and then let the markets sort out what's the most efficient way to cut carbon use. And then you have the second. So this is mitigate, adapt, retreat, right? The 3 approaches. So you reduce the amount of carbon, and then you have the Winston Churchill approach. We'll fight on the beaches and we shall never surrender. So that's the adapt approach, which we're bound to do a lot of because mitigation just isn't moving forward fast enough. And then there's the Scaredy Cat comedian from New York, part of his cabaret act in the 60s, which, when you think about it, I've worked on sea level for a long time. Like I said, this must have been just hilarious in the 60s when nobody had ever heard of global warming or sea level rise or Afghanistan for that matter, right? I've always had an inordinate fear of sea level. Can you imagine how funny that was when nobody thought about sea level? Of course, now we know where Afghanistan is, we know what sea level is, and we know what warming is. So, but still, it represents the retreat part of this triad of approaches that we're stuck with, if you like. Okay, so high emissions, low emissions. So these are the Coastal Commission based on the Ocean Protection Council mean sea level rise. Projections came out a year or so ago, 2018, a couple of years ago, and I want to talk a little bit about that. I'm not going to dwell on this, but I do want to mention a few numbers. So in the next, up to 2050, there is no low emission scenario considered. So up to 2050, it's just high emissions, and that's the graph up here. So 2050 is here, and all of these numbers, this is sea level rise with different probabilities, as you'll see here, relative to 2000. So, for example, here it's a 50-50 chance that sea level will rise 7/10 of a foot, 3/4 of a foot or so by 2050. So 50% it'll be higher, 50% it'll be lower, 50-50, 0.7. The likely range, 2/3 likely range, that's the 2/3 likely range here you'll see in the graph, is between 1/2 and 1 foot. So 2/3 of a probability, 67% probability that sea level rise will be between 1/2 a foot and 1 foot. And then there's this outside chance of 1 in 20 or 1 in 200 chance, 5% or 0.5% at 1.2 or 1.8. Okay, then beyond 2050, then it's divided up into two possibilities, a high emissions and a low emissions, and those numbers are on the bottom. So it's highly likely that we'll see between 1 and 3 feet by 2100 for the high emissions. If somehow miraculously we get on a low emissions trajectory, then we could keep it under 2 feet by 2100. That's what it says here. Okay. Now, what does all this mean? First of all, what will humans do and what will the ice do? So the ice is the second biggest uncertainty because we don't know, especially Antarctica. We have a better handle on Greenland now. Greenland is losing ice mass, but that's only about 20 feet of sea level rise if all of Greenland melts. Only 20 feet. Who has a 2-story house on the peninsula? That's about 20 feet, right? If all of Antarctica melts, which nobody expects, but if it does, that's like 270 feet of sea level rise globally, including here, of course. So just to put that into perspective, nobody expects that to happen, however. I just say that to get your attention. All right. So that high scenario graph is repeated here. The 2000 to 2050 graph is inset, and along with that are the measurements of sea level. So those are the annual mean sea level measured at the LA tide gauge, which is down there close to Palos Verdes. It's in Cabrillo. What's the San Pedro. That's what I was trying to think of. It's near San Pedro, so it may be in an uplifting situation from Palos Verdes because the sea level rise at LA, over the long-term sea level rise over the last 100 years at LA is lower than it is in the most of Southern California. So you have a little bit of an advantage, but that might be just because the gauge is in a funny place. This is a study we've got to do to figure out if this is actually representative of this southern part of the bay near Long Beach. But anyway, there's the projections and the inset. We can talk about this later if we need to. So mean sea level doesn't actually flood anything, though, right? It's when you have high tides and El Niños and big storms and storm surges and big waves. That's what actually floods things. So here is a graph since 1925 when the LA tide gauge, God darn it, the LA tide gauge was installed here. This is the monthly maximum observed water level for every month for the last almost 100 years. So from 1925 to 2019, right, last December, the maximum monthly water level measured. And now this chart is in a datum that you can relate to for engineering purposes, NAVD 88. It's close to mean low or low water, but it's a fixed datum that's used for development and building things, not just on the coast, but everywhere. So the important thing here is that the highest observed sea level is 7.7 feet, NAVD, 7.7 feet, NAVD. Okay, so just keep that number in mind. It's within spitting distance of 8 feet, okay, which will be important in a second. This is from NOAA, the 100-year, 7.6 years, 100-year event. And the point here is that this is a 1 foot by 2030, 3 feet by 2100. So it's kind of a high scenario. This graph shows you how those maxima might increase, right? So the 100-year, the 10-year, the 1 year, and the 1 month. So what you see here, this is called the return period creep, is another way to put this, is that the 100-year event of last, a couple of 10 years ago or so will become the 10-year event. This same elevation will recur every 10 years, and then finally every year, and then finally every month. And for the less intense sea level rise scenarios, of course, this gets stretched out. But anyway, this is just to make that point, that this recurrence. So these high events will become more frequent and more long-lasting than they have in the past. And this kind of gives you a measure of how that might play out. So just remember 8 feet. I said just keep 8 feet in mind. There's a cross-section at 64th place that's not on the map here. 64th place is down here, just about halfway down, a little further down south on the peninsula. This is the berm that is built up seasonally on the peninsula to protect from wave attack and storm surge. And you'll see so the peninsula on the ocean side is 10 or 11 feet, but on the bay side, see you quickly get down here below 8 feet. So 8 feet NAVD is for the peninsula, for Alamedas Bay, is a crucial elevation to keep in mind. And the maximum water levels observed already without the next 50 or 100 years of sea level rise are already within very close to that elevation. Now, I showed this picture. It's the same picture, same monthly maxima, but I covered over I keep pushing the wrong, there we go, okay. I covered over the dates over here, see, because as Alyssa said, we don't know when these elevations are going to occur. There's a huge range of uncertainty, as we saw in the graphs and as we explained, and anybody that tells you we know what sea level is going to do, except probably go up, almost certainly go up in the future, and how much is just unknown at this point for the reasons I said. The point is that I think it's more useful in many ways to think not so much about when, but how much. So mean higher high water, so this is the average of the high waters, is down here at 5-something feet, 5.3 feet. I love how NOAA puts these. HAT is the highest astronomical tide at LA is about 7.1, a little over 7.1 feet. Right, so that's over here. The highest observed water level, Howl is the 7.7 that I pointed out earlier. It was during the El Niño of 2005. Now think about what this means if you have 1 foot or 2 feet or 3 feet more of sea level to your particular situation. That's what we're trying to get at today in this meeting, and I'm sure Jerry has future meetings to the next ice age planned out ahead, okay? All right, just to get you ready. Now, Jerry hinted at this. How will losses actually manifest and unfold? And I am pretty certain, as a coastal oceanographer, I visited, Walter and I had a job in Biloxi. I visited this area, Gulfport in Biloxi. I actually saw this sign, the Waffle House sign, If it wasn't so tragic and loss of life and property, it would have been funny. Just having the sign and a slab, where the Waffle House, I don't know if you've been to a Waffle House, but they have really nice breakfasts there, or they had. In the coast of California, the future is not going to manifest this way, almost certainly. And Katrina, there was some Hurricane Sandy pictures there on the left. First of all, we don't have 80, 100 mile an hour, 140 mile an hour winds. We don't have 23-foot. We really, literally, physically cannot have 23-foot, 28-foot storm surges like they had in Biloxi that, essentially wiped out entire neighborhoods. There was flooding, but it was this massive destruction of entire towns, coastal towns stripped away. I drove inland. There was like inland a mile or a mile and a half inland. There was a huge fishing boat about 100 feet long sitting in somebody's front yard just by this time, a few months later, high and dry. That just can't happen on our coast. The way I think it'll manifest on our coast is the way flooding and damages and erosion have always manifested on our coast, and that is during periods of high tides. If there were big waves, high tides are predictable. Waves are not so much predictable, at least not years in advance, but maybe a week or two in advance. An El Niño, those are not predictable either, but at least we know when they exist for a year or two at a time. And then the storm surge associated with winds and waves and other storm activity. There's been a lot written about this, by me and my students and others, colleagues and people all over the place for a long time. Dan Kane and I wrote our first paper about extreme sea levels and its importance when everybody was talking about mean sea level back, 35 years ago now. So this is also old news about how this occurs, and I'll give you the example of 1983. So in December 1982, we had a series of high storms. So high sea levels, El Niño, big storms. So look when they came in relation to the tide. Came right at neap tide. So this softened up the coast, but really didn't have a lot of damage. And then during January 83, we had a series of storms early on, but then in the 26th or 27th or so, very large storms, huge waves, 10-foot waves, coincided with the highest tides of about 4.5 years. And that's what did all the damage, hundreds of millions of dollars worth of damage. So the tides and the coincidence of all this is very important. If you're interested in what happened last year, or 5 years ago now, Jesus, 2015-16 El Niño, we had a near miss, again, because the tides were not in the right phase. Otherwise, the destruction would have been a lot worse. So you can predict the tides. Like I said, these are the maximum monthly tides predicted for the next 50 years, out to 2050, 30 years now. And you'll see these patterns in here. So there's these 4.5-year patterns, here, higher, then in between. And then you'll see, if your eye is careful, this 18.6 year, and this has to do with the astronomy, lunar motions, the astronomy of the moon. 2014-15, which was all hyped with king tides and the El Niño and all that stuff, those were actually the lowest tides in 2.5 years. See, 2.5 years earlier, 2 years later, those tides were quite a bit higher. And half a foot makes a difference. It doesn't sound like much, but it does. A half a foot can make a difference between flooding over a seawall or not. And the coincidence of the day, the time of day of the high tide and the approaching waves and the storm surge and all that makes a huge difference. So this is very important. And there's your 2005 highest. There's the Howell. So the highest observed water level occurred during one of these 4.4 year peak cycles, which is not surprising. So now you can almost circle, over the next few decades, you can almost circle the years where you're most likely to have floods. Not certain, but most likely, or more likely, just because of the tide patterns. Okay. So Walter and I have done this for where was it? Up here in Northern California, San Luis Obispo for, what was the name of that place? Huh? Yeah, for Unical, but the location, what was it? Avalon. No, not Avalon, Avila Beach. So we would look at the forecasts, we would look at the tides, we would look at the wave forecasts, and we would make some pronouncements. I would get my briefcase, I'd be from out of town. and we would meet, and we not meet necessarily, but send out flood warnings. Okay, next week we have high tides, storm waves, so-and-so, and model shows that you're vulnerable at Avila Beach for those reasons. That could be started anywhere along the coast. A lot of that information is available, and that's a recommendation. Okay, so Alamedas Bay, what was I going to say here? Oh yeah, so this is how it actually will, in my opinion at least, manifest, how the future mean sea level rise will manifest. And it'll be flooding, mostly flooding, especially here where you're largely protected, not totally, but largely protected from waves. And so the progression will be, there may be other, more nuanced other steps in here, but from nuisance, which it is already occasionally, to dangerous and to catastrophic. And I think the big question, one of the big questions that we have to address and want to address perhaps today, start the conversation about what happens after the catastrophic flood, what happens the day after. Your house gets flooded, a house gets flooded, or the aquarium gets flooded, or some public facility. This is very important. It's not just people's houses on the beach. It's also public facilities, sewer plants, power plants, infrastructure of all kinds, harbors, state beaches and parks, the restrooms, the parking lots, the campgrounds, and all of the infrastructure, public and private, on the coast that is vulnerable to this flooding and wave attack. What happens the day after your house, let's say, is flooded? It can't be rebuilt economically. What happens? Who pays? Where do you go? What's the trade-off? And how does that? How do you deal with that? And I think that's the conversation that's important to start now. So that when that day comes, it might be 40 years from now when that day comes. Might be 50 or 80. Who knows? We don't know, as we've talked about. We don't know exactly. But it will come. It will come in the low-lying areas. I think that's virtually certain. That day will come when you can't rebuild your house. What happens? What do you do? Well, okay, so one thing you can do is enhance shore protection. There's a lot of politics, economics, social discussion that has to be happening about that, but that's one thing you can certainly do. We look at these models. Most of these models, there's the USGS Cosmos model, Climate Central has a model, everybody and their brother-in-law, including NOAA, has a flood model. Most of these flood models overestimate the flooding. So first of all, you should be looking at models, or you should be developing models that actually work for current conditions, so you can make a better estimate of what future conditions with sea level rise will actually be. So this is a thesis result from University of California, Irvine, from Timu Galin, who developed a flood model for Newport. And for identical water levels, 7.3 feet NAVD, this was I think the NOAA flood model, or one of those models. There's Balboa Island, completely underwater. And here are her measurements and her model. And you can see that the flooding is much less severe. First of all, the high tide only lasts a few hours. Many of these places aren't connected, right? Even though the elevation might be below 7.3, there's no way for water to get there. So all of those affect drainage, seawalls, just 100 small things actually matter a lot. So this is something that really needs to be done properly for Long Beach. So that's another recommendation, and I'm getting close. So who shares the losses? I have a few things. This is more of an editorial comment. These are my own private opinions. Public and private losses, well, that's not an opinion, that will happen. Public and private losses will occur. I think, this is my personal opinion for those of you that are listening that have power over my day job. I think there's a public responsibility and an interest in private property. First of all, none of these houses were built illegally. Right? You all have permits, right, for your house and your development. Secondly, you've been paying property taxes. Some of you have probably been paying pretty hefty property taxes on your coastal property. So there's a public benefit to and a public responsibility Now, a lot of people say, well, these people shouldn't have built this stuff there in the first place. The low-lying areas, you should have known that you should have known better than to build a house in a low-lying area. Well, but some public agency gave you a permit to do that. Maybe the Coastal Commission even did, including, and your city or your county. So there's some public responsibility here, for sure, and there's certainly financial interest because of the taxes. There's also, I think, a public interest because when the day comes when you can't rebuild your house, that location will probably return to the public. So there's some public interest there in the future, for the long-term future. So I think that all comes down to, the legal and the financial alternatives. And that discussion, I think, should start now for what may happen, or what will certainly happen over the next decades and centuries. Now, what about the mean high water line? I'm going to leave this, only say a few things about it. The mean high water line is a line in the sand at the elevation of mean high water. Doesn't mean much. It ambulates, not so much, well, it does go up when sea level goes up, but that's slower. It does go back and forth as the beach accretes and erodes. But the important point here is not that it ambulates, it's that it's not necessarily the boundary of your property. And so since it's so crucial for permitting, because if you encroach on the mean high water line, if you go seaward of your mean high water line for a revetment, say, or for anything else, that is crucial for permitting, because now you're talking to the State Lands Agency because you're encroaching on state land. And so I would highly recommend that everybody determine where your boundary is, not the mean high water line. That's an easy survey, but it may not be the boundary. Boundaries can be fixed and not ambulatory for various reasons that are complicated. I'm not a lawyer. You should find a lawyer that can talk about that, and then a competent surveyor to tell you where your actual boundary is. And that's really all I can say about that. So this summarizes, this is another one of my favorite quotes. What shall we do, Mr. Thompson? What shall we do? Just a couple of minutes before they blew Dr. Narcisse's head off in Boardwalk Empire. Great show, recommended. We went through all of this. I've used it more in my time than I should. We're going to need a bigger boat, so thank you.
Thank you, Ron.
So I went way over my time.
That's all right. So my takeaways, a few of them. Flooding will go from nuisance flooding to dangerous to catastrophic. The problem is we don't know when that's going to occur. I think it's unlikely that it will occur, though, before 2050. But as you say, it will happen. And it's surprising how little we're doing to get ready, because the longer we delay, the less time we have to adapt. We need to have a wave study. We should develop the kind of model that Timu Gallian has done. She has spoken here about that. And my hope is that we can raise the level of awareness in this city so that we can begin to plan appropriately to deal with this issue. And now we're going to hear from Walter Crampton. He's a coastal engineer. You have all of our speakers' bios in your portfolio, in your handouts, so we're not going to, in order to save time, we're not going to go through those. Walt, tell us what the engineer has to say.
Thank you very much, and I will first say that I've known and been working with Ron since we went to school together back in the mid-'70s, so it's been a long time in coming. So, and again, I am a coastal engineer, I'm a civil engineer, a licensed geotechnical engineer, so I want to give you kind of a path forward and talk about the engineering implications. So we design seawalls, we evaluate coastal erosion, we look at things like planned retreat, and we work with the Coastal Commission every day. That's what I do for a living. One of the things I want to do first is point out, and Ron showed a similar slide, and of course, this is the conditions today with no increase in sea level, but with a 100-year storm. So again, day in and day out. Today, for example, you're not flooded, but if add a 100-year offshore storm and this is what happens to your area of Long Beach. If you switch to just 0.8 feet of sea level rise, and Ron showed this photo as well, this covers a very large area, flooding most of, we'll say, both Naples, the Peninsula, and this entire area. The important thing is that this creates a severe problem. Ron talked about when you might expect this. The state of California sea level rise guidance, this is what the California Coastal Commission considers the current best available science. The interesting thing, what did I just do? Okay. Again, I realize you can't read the numbers, but in this document, they provide tables for 12 different sites up and down the coast to provide return periods of potential sea level rise. And Ron talked about, for example, what happens at 2050. I wanted to talk about, for example, what happens with 0.8 feet of sea level rise, which inundated the entire area. Using this table, 0.8 feet of sea level rise has a 50% chance of occurring by the year 2060, but a 5% chance of occurring by the year 2035. That's just 15 years from now. So again, it's the combination of sea level rise and the 100-year storm, which could occur any day, and that's what you design for, but that's the concern you're dealing with. This shows 6.6 feet of sea level rise for the 100-year storm, and this is, I consider this is a crazy design to even consider. This has a chance of occurrence by the year 2100 of 0.5%. In other words, it's 1 in 200 is the probability of this occurring 80 years into the future. But the reason this is so important is that for an engineer like me, to get a permit to build a seawall for any of you, the Coastal Commission requires that we address this storm today in order to get a permit. So as an engineer, we have to develop and provide adaptive strategies to deal with this storm. This is a storm 80 years from now with a 1 in 200 probability, but this is the permit requirement to build a seawall in Long Beach today. So there are political ramifications to dealing with trying to stabilize your property, and it is the California Coastal Commission who is poised to try to encourage cities like Long Beach to change land use policies today to limit development along the coast, because it is their intent to get people out of harm's way. This is their vision of harm's way. Again, it's 80 years from now when very few of us in this audience will be here, but this is what we're designing for today. At this point, you might be asking yourself, why do we have all of these problems? Well, as it turns out, this whole area has been built within the floodplain of the San Gabriel River. So all of the green, that green margin was the low-lying floodplains of the San Gabriel River, in which we've all urbanized and built the development, albeit at a relatively low elevation, but your urban environment has been built in the San Gabriel floodplain. Now, this is a USGS map showing your area, and again, the important thing is you can see, I can hardly see from here, but even the topo maps show, am I pointing at the right location? Shows a erosion hotspot at the east end of the Long Beach breakwater. And this breakwater is super important for the city of Long Beach. You are so much better off than most coastal cities where you have the full brunt of coastal storms. The Long Beach breakwater provides significant protection for the majority of Long Beach. Now, this is a photograph, both the study area and some wave modeling done by Moffitt and Nichol in response to a study requested by a very small but vocal group of folks that want to see at least a partial, if not total removal of the Long Beach breakwater, because I want to bring surfing back to Long Beach. As you can see over here, the consequences of removing even half of the breakwater will have a devastating effect on the city of Long Beach, your coastal area. And what I would request, the one thing, if you take one thing away from this entire lecture series today, don't ever, ever let anyone talk the city of Long Beach into removing this breakwater. You don't realize the value it provides. Keep in mind, 95% of world commerce is transported by ships. You have a very good harbor here where ships come in and anchor in anticipation of getting into both the Port of LA, Port of Long Beach, and it provides a safe harbor for the ships, but it provides significant protection for the city of Long Beach. Again, this shows the breakwater under construction in 1941, shows the actual design section of the breakwater. The top of the breakwater is about elevation 20. And actually, one of the things that you can do, unlike virtually every other coastal city, if you extended your breakwater easterly 1,500 to 2,000 feet, not only would you provide a little bit more safe harbor for ships, you would completely protect the city of Long Beach from offshore storms. Just something to think about. This is a photograph of the 54th Street parking lot looking to the south. Again, you've got one of the oil, whoops, doing the same thing, one of your oil islands, but you can see in the distance, the end of the breakwater, you can see some ships providing basically anchorage until they can go into the port, and it provides a nice environment that you also have. For example, what the city has done is provide small, I'll say they're primarily intended to keep winds from blowing sand onto the beach, but they also provide limited flood protection. This is a picture of 66th Street, and again, what you have in this location is literally upwards of 3 feet of elevation where all of the first row of houses are built. Ron had a similar graphic of showing the beach berm that is built every winter, and then the elevation at the top of the boardwalk. Again, this is a close-up of the boardwalk about 2 to 3 feet higher than Ocean Boulevard. And then standing on the boardwalk, again, you've got a 2.5-foot little bulkhead of sorts to keep nuisance water from coming over the top. But the city of Long Beach is committed to providing sand in the wintertime. And again, it removed the erosion hotspot originating from storms out of the south pushes sand to the north, and pushes sand to the west. And then every winter, the city drags it back to this erosion hotspot, stabilizing your beaches. This is a nice graphic that we like to show that shows the condition, the existing condition of your castle and the wide sandy beach. With ongoing erosion, what happens is that the beach retreats and you have deeper water closer to shore. The important thing from an engineering perspective is that as any wave approaches the shoreline, they're all depth limited. They will break in a certain water depth. For example, a 30-foot wave will break in about 39 feet of water. What happens is that as deep water gets closer to your castle, it's more susceptible to, number one, undermining the castle itself, but now you get much more wave run-up, much more overtopping, much more wave damage. What we do as a first line of defense is, as engineers, whether you build a seawall or a rock revetment to stabilize, but what we found is the Coastal Commission doesn't like rock revetments. What they do like is beach nourishment, and the beach nourishment then provides protection for the rock revetment. And Ron gets credit for this slide. This is Ron's slides, but I thank you, Ron. He wants credit for that. So this is a slide actually in New Jersey, but the thing is, beach nourishment is something that while you guys move sand very economically, you need to occasionally do beach nourishment. This is Great Lakes Dredging, one of the largest dredging companies around. They did the San Diego County dredging projects in 2001, 2012. This is off of Townsend Inlet, but it's really economic it's putting aside the mobilization cost of about $5 million, a lot of money. Because you're within the outer harbor, it's very easy to dredge an abundant amount of sand to put it on the beach. And you could pretty economically put sand on your beach when one of their large dredges is on the west coast to provide additional stabilization. This is a photograph at Broad Beach where they have dunes, and this is where we've done a fair amount of work, but what we've done is we've recommended a rock revetment to stabilize and protect the property with a stabilized dune, and the stabilized dune provides an attractive environment that the Coastal Commission approves of. So this is still a permittable project, and every time a big storm comes and erodes away the dune and exposes the rock, you just simply come back, re-nourish and recover the rock and revegetate the dune. This is Jupiter, Florida, where virtually much of the area of Florida, these are 20-foot tall vegetated dunes. And let me assure you, if you had a 20-foot tall vegetated dune in Long Beach, you would have no concerns over flooding in Long Beach. Now, when you stabilized with a rock revetment under this, you have eliminated concerns over flooding in Long Beach. I would offer to the detriment of your summertime ocean views. If you raise grades 20 feet, and again, there's a road on the other side of this and then urban development, but you come up over the dune. But this is dealing with the storm surge that Ron talked about. On the East Coast, you have these very, very large storm surges associated with hurricanes. Fortunately, our geology, or our offshore environment is very different. You won't have this on the West Coast. But it illustrates what we're doing in the United States today. On the East Coast, they have very large dune fields, often stabilized by rock revetment to accommodate that very large storm. At this point, because eventually you'll have to raise grades to protect against coastal storms, and again, if you extend your jetty 2,000 feet to the south or to the east, you'll substantially delay that period of time. But this is from FEMA's Coastal Construction Manual. So FEMA is recommending projects like this. They want elevated structures, and this is really designed for the eastern Gulf Coast where you have storm surge. You want your waves, the storm surge, to pass underneath your buildings. But it's just as easy to raise grades. We were talking to somebody before the presentation this morning. Raised wood floor structures are really easy to raise 2, 3, 4 feet. And talking to a gentleman about existing infrastructure, utilities, there are utilities today along the Peninsula and Naples that are still below sea level with the high tides. It all still functions. Slab on grade, it's a bit more difficult, a bit more expensive. You attach all the sill plates. It's a little bit more expensive to raise. They typically replace with a new slab, but you can elevate grades. And this is a nice way of being able to look over the elevated beach berm that you may eventually place. And this vegetated dune will provide substantial protection. This is an example of the Galveston seawall that in 1900, and again, this is on the Gulf Coast where they have hurricanes. The Galveston storm of 1900 killed 8,000 people. It destroyed virtually the entire town, but there was not a single building in the town of Galveston that was not damaged. Another 70,000 people were displaced. And what these folks did in Galveston is that they bulldozed the entire town, raised the entire town 17 feet, and then built this massive seawall, which at the time was the largest seawall built in the United States. And in 1903, it was 3.5 miles long, but between 1903 and 1963, they extended, raising grades, and extended the wall from 3.5 miles to 10 miles in length. So Galveston today has raised their grades, which back in the late 1800s were probably about the same elevation as Long Beach today, but they raised the entire town, so they R-A-Z-E-D, the entire town, imported millions of cubic yards of fill, raised grades. Actually, in this area, modified all of the utilities to accommodate these types of elevations, and then built a whole new town 17 feet higher. So it can be done. Ron hinted on the subject of geologic hazard abatement districts. I'm a big fan of these geologic hazard abatement districts. Prior to 9/11, they used to be called GHADs, and they've since been changed to GADs. But what this district does is it provides you with an ability to facilitate funding. These were originally, it was developed in 1979 as the Beverly Act, intended to stabilize landslides. The first GAD built in California was actually for the Abalone Cove landslide in Orange County that went onto the beach. And remember, the Palos Verdes Peninsula is just one large landslide, but there's more GADs really intended to develop landslide stabilization. I've done 3 GADs, 2 in San Diego for small seawalls, and 1 in Malibu for a much larger rock revetment. But a GAD provides a mechanism to provide much more horsepower dealing with, for example, the Coastal Commission and all of the agencies. A GAD requires a plan of control which provides what the GAD is going to do. So it may be a bit premature until the city of Long Beach decides what it wants to do, what it wants to accomplish. But once a plan is formed, a GAD provides a very good mechanism going forward. I wanted to provide this example to talk about flooding, riverine flooding. So many of the coastal cities that have harbors and rivers, like the San Gabriel River, not only do you have coastal storms that affect the shoreline properties, but if you have a harbor like Alamedas Bay, we're working in Newport Harbor doing the same thing. High tides allow water to come in the mouth of the harbor and flood the inland area. But also, for example, the San Gabriel River, San Diego Creek, inland floods will also flood the backland. So the interesting thing about 2.5 feet of sea level rise is that you still have, and I can't see from this perspective, but you still, if I'm close, you can still see the flood control channel, so it's not inundated yet. With 2.5 feet of sea level rise, the San Gabriel flood control channel is still above water. So it's a relatively economical effort to completely protect against inland flooding from coming into your back bay. All you need to do is dam the mouth of at least temporarily, have a mechanism to dam the mouth of the San Gabriel River and the entrance to Alamedas Bay. So I wanted to provide a different perspective and look at what other countries have done, most notably the Dutch. And the Dutch is a truly unique environment. These folks have been dealing with flooding literally forever. They've been dealing with flooding for over 1,500 years. It was in the 13th century that the Dutch were kind of outgrowing their country, and they decided they needed more land. So they thought, we're either going to go out and war with our neighbors and conquer more land, or maybe we can war with the ocean and reclaim land. They chose the latter, and that's where the phrase, God made the earth, but Dutch created Holland, or the Netherlands, because they have, for over 1,000 years, been working on trying to stabilize their country. One of the interesting things that the Dutch have done, in 1997, they built the largest engineered structure in the world, with a huge structure that cost them $450 million. This is on the inlet to Rotterdam. The Rotterdam channel, ship channel, feeds all shipping into the port of Rotterdam with 450 million tons per year of commerce. It's one of the largest ports in Europe. It provides all coastal commerce. Remember, 95% of all commerce comes by ships, and it comes into Rotterdam. The interesting thing about the Netherlands, just some interesting facts. 55% of the Netherlands is below sea level. In contrast, there's not 1 inch of Long Beach that's below sea level. The city of Amsterdam, the capital of the Netherlands, a population of 8 million people, is on average 7 feet below sea level. So they have a very, very different environment. Why is it so low? There's 3 very large rivers that flow through the Netherlands, flowing to the North Sea. Those rivers are deposited for thousands of years quite a bit of peat. The peat settles, so as they've urbanized the low-lying grounds, and then they dewater the grounds to live in these grounds, the dewatering increases the weight of non-saturated soil, weighs more than saturated soil, so in terms of the buoyant weight of the soil. So you get more settlement. So it's the settlement of the underlying ground along the western half of the country that's caused a settlement. In the Netherlands, the maximum amount of settlement from compression of peat is 22 feet below sea level. The Dutch have built about 3,800 structures, primarily dikes, flood walls, and the like, to protect both from coastal flooding and riverine flooding. And these storm dikes are as much as 20 meters high. That's 66 feet. And these dikes and structures, they have designed these structures so that they're protecting against both storm waves from the ocean and then also riverine flooding. Interestingly, the Dutch have developed a consortium primarily of engineers and some policymakers where every 5 years they investigate, they evaluate both the engineering characteristics and the technology, including both sea level rise and climate change, what effects it has both on coastal flooding, riverine storm conditions. How do they evaluate that? And every 5 years they evaluate all 3,800 structures, dikes, structures, seawalls. This will be one of the 3,800. But every 5 years they evaluate, and if they determine that is not up to the current criteria, and the criteria evolves, as the sea level science and climate change science evolves, their design criteria evolve. And every 5 years, any of those 3,800 structures fall below the design criteria, they go out and upgrade it so that they're in conformance. The Dutch currently use a 10,000-year storm return period for storm waves, for coastal waves. They use a 4,000-year return period for riverine flooding. Compare this with the United States and most countries. Most engineered structures in the United States are designed for a 100-year return period. Seismic design. This building is designed to resist a 500-year return period earthquake event. Its intention is not to make sure that after the design earthquake that the building is still usable. It's to make sure that there's no loss of life. So again, compare what we have done with what the Dutch are doing. We're better than many. A good case in point is the New Orleans floods. The Corps of Engineers knew exactly what the deficiencies were with the levees in New Orleans. They designed repairs. They came up with cost to repair. Congress actually funded the money and gave it to the state of Louisiana, but unfortunately, local politicians found better uses for their money than to rehabilitate the dikes and levees, resulting in the death and destruction of what happened in Louisiana. That's unfortunate. This floodgate in its open position since it was built in 1997. It has only been used once in 2007 with the storm in the North Sea. But you can see the size of this structure. It's one of the largest engineered structures in the world, and its operation is unique in its simplicity. When the water raises 3 meters, it floats these gates off of their resting points, and because of a slight canted design, they actually float together. And when they're about a meter from the from touching each other, they flood the gates and it settles down to protect it. It takes about an hour to open or close the gates. The Dutch and Americans are not immune. This is Venice, Italy, and as you can see, the island is being flooded more recently. By the turn of the last century, they experienced 200 flood events in Venice in the last year before they introduced a $500 million program to close these 3 levees. This shows you the concept of how it works. This is one of the structures that it sits in the dry. These things were built in the dry, floated out, and sat on the seabed. This shows you these 20-meter wide gates with their hinges in place. Same picture without the hinges. Now it's painted. You can see it floating and operational. The problem, though, is that and again, apologies to any Italians in the group, but through graft and corruption, the Italian mafia siphoning hundreds of millions of dollars off, they've run out of funds and they've not been able to completely stabilize, and they're having problems maintaining their facilities, and they're still having flooding. Just another photo of the difference here. And again, compare this with the Dutch. This is an inconvenience, a serious inconvenience that affects tourism, it affects the integrity of the buildings, but these people are not dying. If you had a similar thing happened in the Netherlands, where sea level is 8 or 9 or 10 feet below, if you breach one of the sea dikes, thousands of people would die it destroyed the Dutch economy. So I just wanted to close with a couple photographs. This is again from Holland, and want to remind you that raising grades is not that difficult. If you really think about it, in the Netherlands, they're building what they call polders, where they're actually just demolishing both urban and rural areas, raising grades to rebuild structures. This is a very, very large farming area where they demolished 18 farms, raised grades 20 feet, rebuilt those farms with, of course, all the cows in the low-lying areas. This is an urban town, and this is another polder, but you had an older town that was showing its age, and they've basically raised the entire town, R-A-Z-E-D, and then raised grades to build a new town, completely stabilizing the area. I want to close with the Dutch are also big on beach nourishment, and the importance, remember the picture of the castle. If you have low-lying grounds here, waves can shoal quickly and overtop these areas. So the beach nourishment also protects their sea dikes. And they do lots and lots of dredging, pumping sand onto the beach, which is something the city of Long Beach should do as well. And I wanted to close with the Dutch's current vision for stabilizing the entirety of North Sea. They want to completely dike in the North Sea to the cost of $1.5 trillion. That's a lot of money. Surprisingly, England, Ireland, there's a lot of folks that are getting flooded with serious problems. At $500 billion spread over 20 years amongst the 14 countries that are adjacent to the North Sea, it amounts to 0.1% of the collective country's GDP. Thank you very much.
Thank you, Walt. So I think the European experience shows there are a lot of things you can do with engineering. The costs are high, but the savings also are enormous, plus what you do in terms of diminishing social disruption. It also shows, I think, you have to take the long view, which is something that we're not very good at in the United States. I'd like our two speakers to come up front for just a couple of minutes. And then we're going to bring the house lights up, and we're going to see if any of you have any questions or comments on what you've heard so far. And Alyssa's going to come up, and she'll introduce our next speaker. But come up, you guys. Who has a question or a comment? And then what I want them to do before we go to the next speaker. We have a leading oceanographer, a leading coastal engineer. If you look at Long Beach, what would be your 10-point program? And you say you have to know what you want. So I'm going to tell you, this is a personal perspective. Given that sea level rise affiliated with the RCP, the Representative Carbon Pathway, for 8.5, because I think that's likely to continue on. And if the goal is to keep people in their homes and their businesses for as long as is practical, what would we do? Now, clearly, by the end of the century, if we get to sea level rise of 20 feet or so, it changes the game. But we've got a number of decades, and this idea that the Coastal Commission has with 6.6 foot rise of sea level and a 100-year storm, that's clearly a black swan event, low probability, high impact, and I want you to give us kind of the gray swan impact. What would you do? What are the 10 things that you would recommend?
I would say from an engineering perspective, the first thing is to encourage Congress to extend your LA breakwater another 2,000 feet to the east. What that does is it completely eliminates storm waves from the city. It also eliminates the need for the city to do all of this grooming every year. But at the same time, you still need to add more sand. Eventually, you need to add dunes, and I would propose that you could probably install the dunes even without the rock with the jetty. So those are all good things, but to protect the inland areas, Naples, Belmont shores, you need to eventually slow down the opportunity for water to flow into the inner harbor, and that, in my mind, requires a gate.
Oh, okay. So, Ron, in terms of scientific data and information, what are the things that you would give the highest priority?
Well, I guess I'll have to defer to my own slide, right? I mean, I had a list of about 10 things, which I can't remember. But I think as far as studies, well, I'm getting old. Not as old as him, but old.
Yeah, but you're losing it.
I'm losing it faster. That's true. That's damn true. As far as the studies go, I think that the two priorities, as I see them, are the flood study, highest priority, and then the wave study. But those really go together. You can't really do the flood study without having the wave study. And I would point out one thing, and it was in one of the slides, and Walter mentioned it too. And it also shows up this thing, this flooding. The way the floods in the peninsula occur and in Naples, the backside of the peninsula, the bay side of the peninsula, is much lower than the ocean side. And if you look at the flood models that overpredict the flooding, right, you can see it very clearly. The flooding from sea level rise and from storm surge and from everything that's not waves, right? Because waves, presumably, except maybe boat wakes or a little bit of wind wave activity, don't get into Alamedas Bay. But the still water, the high water flooding comes from mainly at this current situation, current time, from the backside, right? From the Alamedas Bay side more than it does from the harbor side, right? From the ocean side, if you like. So I think that's really important. That's something I learned in preparing, for this after Jerry invited us up here. That's something I learned, but it's not atypical because it's similar to Newport. It's in some respect similar to Imperial Beach, and this is another important point that I didn't make earlier, but I think is absolutely crucial. Except for the difference in the wave attack, the peninsula, the low-lying areas in Long Beach, are not special in any case. This similar situation occurs in all of these barrier spits, literally from Imperial Beach in the south to Humboldt in the north, right? In the very northern parts of California and on into Oregon and Washington as well. So in Southern California, we're sheltered from waves, so compared to the central and northern California, Oregon and Washington certainly. And so we see these more effects of these high tides occurring during El Niños, where the elevation, sea level are jacked up a half a foot, say, for a year or two. And so the water levels are relatively more important compared to the wave activity than they are in Northern California. Northern California, Central California, the open, exposed coast of California, Oregon, and Washington are much more susceptible to wave activity than they are to water level. Here, it's more of a balance, right? The water levels are relatively more important because we have less wave activity because of the sheltering effect of the islands offshore and the general topography. So I think in order to make good predictions and good engineering and good forecasts about how things are going to evolve and what's going to happen that day after you can't live in your house anymore, or you can't use the park anymore, or the parking lot, is to improve the understanding. And that is available, right? The science and the scientists and the engineers are available to do that for the local cities. They just have to ask, and the counties and the state as a whole. Now, this also brings up something that is a criticism, and I know Jerry shares this. The state, in our view, has not done a very good job in coordinating all of these separate little studies that have had that they funded, right? The state, the Coastal Conservancy, and the Coastal Commission, and others in the state fund a large number of individual cities to do their own sea level plan, and relatively few of these are they're just not coordinated. They're disconnected in many ways, and so you don't have a uniform, or at least a more unifying type approach and common science. There's reinventing the wheel in every small town along the coast, in essence. And I think this is starting to trickle up into the state's thinking. And I've heard talk about how do we manage this better? And I think that's an important part of this whole picture.
And that is captured in the recent legislative document on coping with sea level rise. Who has a question? Yes, go ahead. What's the cost per linear foot of extending the breakwater?
I'm not sure.
Any idea in range number form, though?
I hesitate. I'll say
It's a
big number.
It's
That's an easy number to come up with, but a big number.
it's a big number, but on the other hand, what you save if we lose all of these homes and these properties, it's a big number. I gather you guys wouldn't subscribe to the theory that we should sacrifice the peninsula as a gift to the gods so it'll stop rising sea level.
I'm sure it's cheaper than repairing all of these homes.
I think you're right. Yes, go ahead.
I have a question about whatever the solutions are. I'm really distressed that the city of Long Beach is not here and part of this conversation. It's state, we've got Thailand, and we've got State Lands Commission, we've got county, but the city of Long Beach has to be part of this discussion.
Oh, somebody's.
Are you guys actively participating in planning? Because frankly, I haven't seen any of the city of Long Beach leadership taking an active role in dealing with this.
We've been involved. You can also check out our climate action and adaptation plan.
Yeah.
So there is a plan.
There's not a plan.
Is that Mel Nutter in the white hair?
Let's see where.
There in the white hair.
Yes, it is. It is. Okay.
You should call on him.
More front and center and taking an active role in this dialogue because, in better words, it's going to be the city of Long Beach that's going to have to coordinate many of these solutions that are being talked about in the site. Thank you for being here.
We'll take one more over here.
Reality check on the CAAQ plan that the city of Long Beach is working on. It's in a draft form. It's been subject to community meetings and input from the public, but that plan is still in a draft form. It was open for public comment last summer.
Okay, and Mel Nutter, you've been at this for a long time. Do you have any comments to make that would be enlightening as to what we should be doing?
Well, I'm not sure, but I can say that the science and the awareness of sea level rise certainly is far more prominent than when I was chairing the Coastal Commission. Sea level rise was not even really an issue amongst the decision makers, and so we certainly were approving a lot of things that it would have been nice to have this information about back then. And I'm very interested, of course, in hearing what the engineers have to say, because one of the things it really seems to me is important is that we keep our minds open as to the knowledge and information that is being developed. I found, for instance, the discussion about what the Netherlands is doing rather remarkable, and whether some of that translates into what we're doing here or not, quite aside, there's really a lot of information, and I'm most appreciative that you're pulling this together.
Thank you. And I think one of the real deficiencies that we have is the rate of scientific and engineering knowledge and information is accelerating, but the rate at which it gets incorporated into management and policy decisions lags significantly, and we need to shorten that lag time if we're going to take advantage of these advances. Alyssa, you can make a comment about this session, and then you're welcome then to introduce Giuliano.
Hi, everybody. I'd like to introduce Dr. Giuliano Khalil. He's a researcher at the Middlebury Institute in Monterey, and he's developing a virtual reality tool to help us visualize some of these impacts, as well as visualize some of the solutions of what's possible. And so, Giuliano, if you want to come on up.
All right. Thank you, Jerry. Thank you, Alyssa, for the introduction. Thanks, everyone, for coming. Is this the clicker? All right. Big green button. All right, cool. So I'm going to talk about this tool that we're developing to help to communicate some of these issues and talk about the solutions, because even if we had the answer today, how would we get it from an idea, from a plan, to actually getting it implemented? So we need to get a lot of people on board. We need to communicate the science, the problem, solutions, and there are a lot of diverse audience that really needs to be engaged with this. So I think this map came up a couple times in the past, so this is how we traditionally communicate some of the flood risks that we see. And this, I think a lot of us are used, and if you're engaged with these processes, you're used to seeing things like this, where there's a map of like a Google view of a region, and then a blue area depicting some sort of flooding. But it's kind of complicated. You have to spend some time to really understanding what's happening behind it. You know, what is the scenario? When is it going to happen? What is included and what not? And even when you do a good job of doing that, about a month ago, I found this gem online. It was a study from two professors from Georgia University. They interviewed over 1,000 homeowners in Florida, and then they showed some flood maps to some of them and didn't show to some others. And I'll read the quote that what they found is that, surprisingly, those who had viewed the maps were, on average, less likely to say they believed that climate change was taking place than those that had not seen the maps. And regardless of political affiliation, the majority of homeowners denied that there was a risk to their property values. So I was kind of shocked, but it's, and through the last couple of months, I'm going to talk about a couple other projects that we're working on these tools. And I had a chance to talk to folks that are not engaged, that are not used to this. When you reach out to someone that is not engaged with sea level rise or doesn't know much about climate change, how do you communicate some of these concerns to them? So for the last couple of years, I've been kind of researching virtual reality and why did we decide to pursue this as a method of communication. So there's emerging research showing that VR promotes pro-social behavior change, preparation for natural disasters. We're collaborating with a before I get to that, I'm just going to say there was a study done by 2 Dutch scientists in 2013 that showed that folks that experience flooding in a 3D environment declared a higher intent to evacuate from flood-prone areas, but also to purchase flood insurance. And this wasn't VR, it wasn't fully immersed, it was just like a 2D, like a computer screen with a 3D, like a video game that you could navigate through it. So we're working with a team in Stanford. They have a virtual human interactions lab. So we're developing a social study to see how would the use of virtual reality maybe change people's intents and perceptions related to this issue. And we're also adding this question, when would eventually people even declare, is there an intent to relocate from the coast or not, based on how they see some of the issues and deal with some of these uncertainties. So the first project I'm going to talk about is in Santa Cruz. We started this over there, and this is a problem, as we heard, is not just here in Long Beach. So this is the West Cliff Drive, if you're familiar with Santa Cruz, and the city is working on 2 projects at the moment. One was founded by Caltrans to look at the transportation impacts on the West Cliff Drive due to sea level rise, and another study funded by the Coastal Commission to look at coastal access to the beaches there. So this is kind of the boardwalk, and this photo was taken during a little past the king tides in 2019. So you can kind of see the high water level there. I mean, it's almost at the boardwalk already. You can see some of the vegetation there. So it's already hitting our kind of borders there. And before I go I just want to show you a little bit on how we do this, how we develop these tools. We start with flying a drone in a kind of search grid pattern. And we were here maybe a few months ago. Alyssa and I were running up and down the peninsula, flying the drone and taking some pictures. This is a model from Santa Cruz, but I'll show you some of the Long Beach. So we fly the drone, we get the still photos, we create a point cloud, and then we make it denser. And then we create a 3D model on top of it, and then we project the results of the photos into the model to make it like texturized. And these models are pretty accurate. They're within a couple of inches. Oh, yes. Could you turn the house lights down, please? I see someone walking over there. You couldn't see anything so far? Oh, all right. And to go back is the red. All right, I'll just let it play for a minute so you guys can see. And in these pictures, you can see already some armoring that's been done, so it's heavily armored part of the coast there. All right, so this is the drone flying. You can see kind of a point cloud and make it denser, do a 3D model, and then texturize it too, so we can recognize. And these were one of the first generation projects that we've done for the models. So the models that we're developing for Long Beach, they're much crisper. So once we get those 3D models in place, so we're loading them into this virtual reality room. So it's a kind of a place that you're immersed, and then you see these models. And over here, you can see a projection. This is Cow Beach, a famous surf spot in Santa Cruz. The boardwalk is just to the right. And here you can see a projection of 2.4 feet of sea level rise combined with a 100-year storm in the city as well. So one of the things that we find is that people, when you recognize the building, you recognize some of the places, it really changes the way you perceive some of that information, right? And the folks that we're working with at Stanford, they're doing some research, and they've showed that in virtual reality, you can interact with the environment. You can pick things up, you can walk around, you can move, you can look around. And they found that the folks that move the most inside those environments, the virtual environments, they also retain more knowledge. So one of the things when we see maps, when we hear words, and we read things, there are parts of your brain that get activated. But when you're fully immersed in an environment like this, the parts of your brain that light up are the same parts that light up when you're actually seeing the same things. So they did like functional MRI, and they found that it imparts like a whole different reaction, emotional response, and physiological even in a sense. So with that in mind, we developed this tool in a very interactive way. So one of the things that you can do is there's a bar, and then you can slide that bar and look at projected sea levels as you slide the bar. So you have some agency and control over the experience. You can move them back and forth. And we also included other features, so it's going to be available in Spanish. We have a survey that's built in that we can activate if there is a need. We also talk about adaptation options. And one of the very popular features that we have is what is called the aerial view. So when you click on the aerial view, you're projected, you're kind of transported to this blimp, and you're kind of flying above the area. And this goes from a movie taken from the drone to the application in here. And as I mentioned, the parts of your brain that lit up are kind of different. So if you're a little afraid of heights when you're flying on the blimp, your palms may sweat, your heart beats a little bit more, so you get the same kind of reactions that you would if you're kind of up there. So it's a very interesting, and then you can look around and explore some of the areas. And here again, you see the projected impacts of 2.4 feet of sea level rise with a 100-year storm, which like a high probability of happening in that area, I think by 2060 to 2080. So the city, we developed this for Santa Cruz. It's a little far ahead than the one in Long Beach that you have a chance to try in a few, like after I think we're done here. We have some of the headsets available if folks want to take a look. But we had this application available at the public library in Santa Cruz for a little over 3 months. So we had about 240 people went in, and you can check out the goggles and try them out. It takes about 7 minutes. There's a mini survey that we ask people. So one of the great things about this technology is it engages a different audience. So those are folks that are walking into the library, they see this big pamphlet or like a panel talking about sea level rise, the projects that the city is working on, and then you get to see it and participate, and almost everyone says that they want to hear more. They provide their email, they want to hear what the city is doing. And it was really interesting. So 240 participants so far. We did this very brief mini survey. We just asked people, rate how your awareness of sea level rise has changed as a result of the experience. Tell us what you liked about it, what you didn't like. And I didn't finish compiling all the responses yet, but of the 143 that I did, about 77%, so 110 people declared that their awareness changed as like 3 or 4 out of 4. So it's a very significant way to have people understand better what's going on and some of the issues. And here's some of the quotes that we heard from the surveys, that having controls of the ocean rising makes it visceral. I'm pushing. Oh, there you go. They all came up at the same time. So someone said, I studied sea level rise, but it really made it a reality. It's not just words anymore. I was relatively aware, but having point of view visuals was very impactful. 3D experience is much more powerful than photo models and drives real reality home, even though it's not real, right? It's just a projection. It's like a simulation of what's going to come. We don't, like it was said here before, we don't know exactly when it's going to come, but we know it's coming. And just last Wednesday, or Thursday, there was an open house at the city of Santa Cruz. So it was like a community event. About 100 people showed up. I think we got 52 folks went through the VR experience. And one of the comments that we heard, we had it was a big auditorium, like on the convention center. So all the teams that are working on these projects were there. So we had the engineers, the economists. We were there with the VR. The city was there. So it was a very comprehensive event that happened, and we were at the last kind of station, so folks would go around, and then we heard from almost everyone, it's like, oh, we should have started here, because this makes it so clear. So now we're rethinking how we do that, and we have like a 7-8 minutes experience that really tells the story, I think, in a compelling way. Okay, so that was the project in Santa Cruz. I just want to briefly talk about another work that we did in Maryland. So this is on the Chesapeake Bay, a community called Turner Station. And it's a traditional low-income African-American community. And they're dealing with their issues there with sea level rise as well and some projected flooding. So we met some of the residents that grew up in this region playing baseball in those fields. And the kids can't play there anymore because it's always wet. So it's just... you can walk there, but I was there flying the drones and my pants got wet. It's like during high tide, it's really bad. So we did this work, and the idea there is that the Baltimore harbor is dredging some of the channels because they want the largest ships now that they built. They want like 2 of those to get into the harbor like side by side into the channels. So they're going to have a lot of dredge materials available, and they want to provide that as a solution. So the plan here, and I'll play the kind of the 2 animation, is to bring that dredge material around this park, raise it, put some soil on top of it, and come up with kind of a living shoreline solution. And one of the things that I liked also about this VR projects is that it starts unexpected conversations. So one of the things, when I did this, we used NOAA's sea level rise projections for this. And if you look to the right, there's a neighborhood there. So that was not in the scope of our project. But when we designed the 2D kind of specifications and we sent it to the artist to do the rendering of the flooding, I forgot to tell him, like, that's not part of it. And then when this came back, I put the goggles on for the first time, and I knew all about this area in the project based on the research. And still, he gave me this, I was like getting punched in the gut. I was like, oh my God, what are we going to do about that? We're not talking about that side of it. And because of that, now, when we had a long discussion, should we keep it? Should we take it out? How are people going to react? And this was, there's an NPR story that came out that's really great. It was on Morning Edition, if you want to look it up. There's some of the reactions of the residents that are quite strong when they saw some of the things that they were looking at. But we talked to them, and now there's great interest in addressing the issues to the neighborhood as well, which is great. And then we are here, Long Beach. So as Jerry very well put, so what could be done so residents and business can stay where they are for as long as possible? So I got the cartoon from one of our previous meetings. We had an artist kind of documenting the discussion. I thought it was great, so I have some of that here. But before we get to the cartoon part, so this is one of the aerial views that we did for Long Beach. And in here you can see the sea level projections from 0.8 feet of sea level rise, and onwards. But one of the things that was also said, and this is something that we learned when we saw this, and you can't, I'll play this again, you can't really tell this by looking at a 2D map, which is this idea, if you look at the water, it floods from the bay, as Ron just mentioned. So even with 0.8 feet of sea level rise, there's some areas in the back that get significant flood. And then we just overlaid with a 100-year storm just to see how similar it is, and then with 4.9 feet, then the whole area. But that's far in the future too. It's just to kind of show what's coming. But it was great to see the peninsula side kind of showing up first. So this is one of the 3D models that we have in the virtual reality tool for Long Beach. We have 4 of them covering the entire peninsula. And here again, you can see the water kind of coming in from the inside, from the bay side. And one of the great things also about the virtual reality is that the headsets that we use, they're very cheap. They're about $150 now, but they don't handle a big model. So we can't put this all 4 models together there. We have to do one by one, but you can see them here. There's a little delay with the clicker, sorry. So I'm going to play that again. And also, while you're playing that, I'd like to acknowledge Paulo and Gian are in the back. They're part of our team. They're really the ones that make all this magic work. So they came a long way to be here. I'm happy they could make it. If you have questions, technical questions about virtual reality, these guys are the best that are out there. All right. This was a photo from that event that I mentioned where we had a focus group. Like it was a hearing session. You can see Jerry and Alyssa. Jerry's in the corner. And Alyssa there, and then we had this great artist that did this cartoon of the event. I'm just going to focus on a couple of things here. Almost done. So what can be done so residents can stay where they are for as long as possible. Then we showed the VR to some of the folks as well, and it was very interesting conversations came out of it. Someone said, oh, can you show my house flooding? I was like, well, we're not ready yet, but why do you want to see that? So it was kind of an interesting, people get really curious about what can be done. So long-term, short-term, and here's some of the reactions. Wow, what would it look like? So one of the great things I think about VR is that what would a 10-feet seawall look like? What would the dunes? If you put like 20-feet dunes on the ocean side, by the way, you also need them on the bayside. I don't know how you surround everyone with sand dunes, but we could show you what that looks like. You could put you in the headset, you'd be standing on the dune or at your house and see what that would do. So this is a very powerful communication tool. We had a really great brainstorm. Some of the ideas that were brought up was like talk to millennials, not boomers, increase the sand dunes on the peninsula, really look at short and long term. So these are comments from the residents that were there, which was a really cool event. And surprisingly, and that was great, I think the tone, and this came from the participants, like I believe there is a positive future for Long Beach. So that's, I really like the attitude. I think we need vision, we need imagination, and really need to get everyone on board with this. And it is a wicked problem. So very briefly, some key takeaways from all these projects, and it's been for me an amazing opportunity to step out of my bubble and talk to people that never heard of this and see their reactions and see how they respond to some of those things. So key takeaways. I learned nothing. All right. So VR attracts and engages a very diverse audience, which is really good. The costs are finally low enough that you can deploy this widely. There are other cities doing this. So we did Santa Cruz, Long Beach, now Baltimore. There's a USGS was doing something in Hermosa Beach and in Capitola. So I'm talking to some folks in Florida that are developing VR tools as well for outreach. Another thing is that to make sure to include solutions. So a lot of you if you try the app now, you see it's mostly focused on the issues, but that's why we're here. So we're going to get input from all of you and choose maybe 2 or 3 options that we can include into the virtual reality. So when you're flying on the blimp, if you're not afraid of heights, you'll be able to see what would a massive sand dune look like. So you'll be able to look down and see that. And I think that really helps to drive some of the decisions. So some exciting things that we're working on next. So we're looking at, as I just mentioned, adaptation alternatives in 3D models. Next week, the team and I will go to Paradise in Northern California. So we're developing a tool for them to, after the devastating campfire where like more than 80 people died and 17,000 structures were wiped out by that fire. We're working also with the Nature Conservancy and the Parks and Recreations Department there to look at maybe how could we use open space as protective buffers, how can we rebuild the city in a smarter way. We're doing that social experiment with Stanford, and also we just applied for a big grant to look at this idea of cascading events in Portland. So we're looking at what if there's an earthquake followed by fires and then there's a mudslide. It's like, I kind of feel terrible about that, but the good thing about that project is that it was a big grant, so we have fire experts, seismologists. It was a big team with the best on each one of those areas to kind of put their brains together, see what would happen if these things converged, but also what can we do to reduce risks from each one that could benefit the other hazard as well. It's a very comprehensive way, and we're going to use the virtual reality to do community outreach there and show some of this. And the follow-on to that, it would be like a Three Sisters idea where we do Portland, Manila in the Philippines, and then Tokyo. So for a second phase. And if you are interested, and if you have, we use the Oculus headset, Oculus Go, and the Quest. If you have no idea what that is, don't worry about it. But if you have one and you're interested in downloading our tools, just email me. The Turner Station is available. They're all free. Who wants to develop them? Part of the contract is that we have to make it available to the public for free, widely distributed. And then the Santa Cruz and the Long Beach, if you send me, I can send you an invitation for a trial for the current version of it as well. And if you want to know more, you can take a scan of that QR code there or talk to me, and that's my time. So thank you so much.
Thank you. A couple of comments, and then we've had a request for some comments by the city. I think the comment that there can be a positive future for Long Beach. It's true, but only if the city begins really to act and move on this. Remember Will and Ariel Durant in their Lessons of History said, the future never just happened. It always was created. And sometimes the future is created by not doing anything. We have time for discussion, and I want to, we're going to talk about what kinds of data and information we need really to make better decisions. Could we, for example, put into the Cosmos model some of the modifications that have been suggested by Walt and Ron and see what the manifestations of those interventions are. Because with VR and Cosmos, that doesn't tell you when this is going to happen. It tells you this could happen if there is no intervention at some time in the future. We know that we need to have better information on the wave climate. We need to have better models. You need to have better data that those kinds of dynamic models require. I don't know what the price tags of doing that research would be, but my guess is it's in the hundreds of thousands of dollars probably, not in the millions of dollars. We did spend $3.5 million looking at whether we should remove all or part of the breakwater. So maybe if you look at it from that perspective, we could figure out how we could justify that. So, Allison, would you like to come up and make a few comments?
Hi, everyone. My name is Jennifer Lee. My colleague's name is Allison. Hi, so I just wanted to take a couple of minutes to just address, have the opportunity to address the audience. We have been present, have been invited to present at various Aquarium of the Pacific events, but I realize that today's topic raises a lot of questions about what we're doing for sea level rise. So I just wanted to share a little bit of background on the city's climate action and adaptation plan. That's the CAP. So we've been working on developing it for more than a year and a half now. A brief overview of the plan is that it has about 20 mitigation actions and 20 adaptation actions, recognizing that 10 years ago, cities were doing mitigation studies to cut carbon emissions, and now we're recognizing that climate change impacts are here and that we need to be acting to adapt. So 50% of the city's emissions come from transportation. That is very similar to other cities. So transportation and energy, and then the last category is waste. So we have 20 actions that address those three sectors. And then on the adaptation side, we are looking at extreme heat, air quality, sea level rise and flooding, and drought. So the city's role is really to look across the entire city and look at impacts of climate change. We've also done social vulnerability analysis and are looking at especially how that really overlaps with a lot of the heat and the air quality impacts. But within sea level rise and flooding, we cover physical and natural solutions as potential actions, and also some that relate to governance. So from the city side, we'll be looking at things like updating the floodplain ordinance, looking at additional studies that can be done. Managed retreat is something that is potential for long term. We have kind of a breakdown of short, medium, and long term in the draft CAP. So the CAP is in draft format right now. We hope to have it adopted by the end of this year. Right now, the way that we're doing our CAP, a lot of cities are using their CAPs as a policy tool. For us, we are doing a qualified CAP, which means that we have to identify and find the commitments for reductions to greenhouse gas emissions and knowing exactly where they're coming from. So we are working with our various partners to identify where those emissions reductions are going to come from. And then just to give you an idea of outreach, so we have reached an estimated 10,000 residents over the last year and a half of outreach. That's viewed as successful by the city, but it's still really, 2% of Long Beach's population. So, we have a lot of work to do outreach. We've had a scientific working group that has also informed the development of the CAP. And I think that's what I'd like to share for today, I'll be around in the morning portion, and my colleagues should be coming in the afternoon. So please feel free to reach out to me. We have on our website, so if you search CAP Long Beach Climate Action and Adaptation Plan, we've been really good about putting all of our resources online. So the draft CAP is there. All of the documents from our various meetings over the past year and a half are there, and please feel free to reach out with questions. Thanks. Oh, sure. Mm-hmm.
Any questions for Jennifer now?
Yeah, we do have, there's been some community comments about phasing out oil extraction, and because of that, we've developed an oil and gas memo that's also available online. So because of the community asking us for a more ambitious cap, we're aiming for 2045 carbon neutrality and looking for pathways to do that. I think that's. It's well, specific projects wouldn't be in the memo. The memo covers just more of a general pathway in terms of the technology, emissions that are coming from oil extraction, upstream and downstream emissions, and how we might get to net zero by 2045 generally, but it wouldn't cover a project-specific level. Mm-hmm. Yeah, I agree. Mm-hmm.
Anybody else have a question? We'll take one more. Go ahead.
I just want to say, Jennifer, thank you very much for this impromptu update on the city's plan. It's extremely helpful to me, and I would like to suggest that going forward, there always be a city representative at least giving an update on where the cap is and focusing specifically on this flooding and sea level rise issue. I mean, I think everyone in the room obviously identifies that as a priority, and recognizing the cap has a bunch of different things going on, but if someone could come from the city and be participating in this.
We will make the commitment that every time we have one of these, we will invite someone from the city to be on the program. I would just like to say, we, as a state, as a nation, we've put a lot of emphasis on mitigation. That is reducing the driver of climate change, greenhouse gas emissions. And while that's a good thing to do, I think we need to shift the center of gravity to adaptation, because if you look at us being on the RCP of 8.5, which we are, in the last 2 years, global greenhouse gas emissions have gone up. And if you think about the atmosphere is a commons. It has a mixing time of about 1 year. 60% of all greenhouse gas emissions come from Asia. So what we do in the United States, while it's important, it doesn't change things very much in terms of climate change. So we've got to put more emphasis on how are we going to adapt to the inevitable while we are also trying to reduce the driving force. Now, I think I'm going to depart from the agenda because I think many of the comments have already been made. about some of these things in terms of what kinds of research that we need. We will come back to it. But I want to ask Wade Martin to come up. Wade is a professor at Cal State Long Beach, and we have had a group of his graduate students have been working on this project to add an economic dimension to what would be lost if we don't do anything, if we were to lose the homes on the Peninsula, Naples, and businesses and homes in Belmont Shore. Wade.
Thank you, Jerry. First, if you look in the brief bios or whatever, there was also Ingrid Martin was going to be here, but as the press telegram just said, there are now some coronavirus cases on campus and some quarantines, and so being in administration there, she has had to go to the campus for emergency planning meetings. So she regrets not being here. She is the director of the graduate programs in the College of Business. So the program that Jerry mentioned with the students is part of the Saturday MBA program. And the Saturday MBA program is targeted toward working professionals. So these are mid-career individuals that have mid-management positions and are looking to move up. So what we do in the Saturday program in the second year is we focus on using the tools that they learn in the first year of the program to address issues such as sea level rise with business tools like benefit cost analysis, for example. And what we do is put together teams of students that are these working professionals, so it's like a consulting team that will work on a specific issue and look at it from managerial perspective. And we've worked with the Aquarium on several issues over the year. This is, I think, the 10th cohort going through this program. And the focus is on sustainability and looking at things called with the lens of the triple bottom line. So we're looking at society, the environment, as well as business viability. And so this team was charged with identifying and analyzing strategies in the short term, midterm, and long term, and to provide more of a financial analysis for each set of strategies at each time level, time dimension. And specifically, it's not just looking at it from a cost engineering perspective, but also trying to integrate some of the benefit side, sort of what are we getting for all of these investments as well. And in the short term, the focus has been primarily on what the city is doing to establish floodplain ordinances. It's been mentioned here. Looking at incorporating sea level rise into city plans and regulations. How is the cap going to be operationalized? How to restore natural sand dunes, which was mentioned, flood-proofing the sewer pumps, the infrastructure in these vulnerable areas. So each of these have costs associated with them and respective benefits. So are we truly getting benefits that are greater than the cost? In the midterm, we're looking at in the short term, it's up to 2030, so the next decade. The midterms, 2030, 2050, roughly. So there we're looking at things like relocating, retrofitting, elevating critical infrastructure. And as you can see, all of these issues we're looking at have been mentioned by the previous speakers and as viable options moving forward. Extend and upgrade existing seawalls, retreat beach parking lots and recreational courts. So we look at it from the perspective of whenever the natural cycle comes to rehabilitate these lots, do we just use that opportunity to move them as opposed to continue to upgrade them in place, in situ? Beach replenishment, we've talked about how the sand is moved, how the sand is relocated from west to east. Construction of a berm and the increased shoreline at Mother's Beach. Elevate and extend the curb on 2nd Street. I thought the example of Galveston was very interesting, although I can't imagine raising everything and then raising it. But it does show what can be done, what is engineering, what is feasible from an engineering perspective. And elevating streets and pathways. So these midterm options, although not exhaustive, do provide an example of some of the potential actions and trying to provide more information about the trade-offs that exist and what the benefits and costs are. In the long term, 2050 to 2100, there is discussions about what does managed retreat mean, where would people relocate to, should relocation be appropriate, be the strategy that is chosen. So the long term obviously is much more uncertain as to what the policies or what the strategies would be. As you get further out in time, the uncertainty increases. And another part is looking at potential funding sources. Where will the money come to do all of this? And also, what impact does it have on the city's budget and revenue sources as businesses relocate? Will, say, businesses on 2nd Street relocate to Long Beach, or will they just relocate to Seal Beach further south or inland? So are we going to lose part of our tax base there? All right. And so this project, I think the students were here at the November meeting, and it's where they came up with many of these alternatives that they're evaluating. Unfortunately, this is for working professionals, so they had to go to work today, and you were stuck with me. This report should be to the faculty by April 18th, and we will review it, and I'm sure it'll be perfect the first time, but it will be available by the end of April. All right? Thank you.
Anybody have a question before he sets down? Let's bring the house lights up so we can see, okay?
Yes.
Tell me.
Yes.
Insurance solutions or mortgage-backed security risks there?
Yes. As far as the insurance, there is the issue of flood insurance, but that's on private sector insurance, the government insurance programs. And looking at insurance much more from the perspective of how much insurance do you buy to mitigate against climate change, but not what a household level decision to insure would be, if that makes sense.
I was just asking whether the program was looking into insurance solutions such as resilience bonds and so forth. As part of the investigation that you.
No, we have not gone down that path and looked at bonding and insurance. We are reviewing the Corps of Engineering reports and seeing what their estimates, because they did a benefit cost on that. Yes? Yes, and part of we're looking at probably 10 different programs that have funding available for coastal infrastructure construction. But given the port, and given the wave impacts on trade, the argument is made that the benefits will exclude or will exist beyond Long Beach as a justification for funds from a more general source would be legitimate to use on this. However, the truth is no one source is going to pay for it all. There will be cost sharing and multiple partners in any action that will be taken.
Looking at the city of Long Beach's unique revenue source from Tidelands funds, or
That is one of the 10 sources we are looking at. Absolutely. Yes.
Do you have any idea as to how much of the assets you arose from Naples, Peninsula, or Belmont, and the Peninsula? Do you have any idea, please?
I think that's an impossible number to know because you don't know what, as they mentioned earlier, what the human action is going to be to help mitigate the impacts. Yeah. We will have, yes, we can calculate that number because we do have things like the mean value of the house and all of that. So you can value the real estate. One thing is to understand there's the quantitative losses as well as the qualitative measures. And as Jerry mentioned when he started talking about the social sciences, sociology, the community disruption and all of that, trying to estimate the value of the lost infrastructure, that number can be obtained. The relocation costs, the emotional costs, those are much more challenging, obviously, to estimate. But yes, we can end up with a number, and we know the tax base there as well. Right. No, and I think that as I think Ron mentioned with the study in Newport, what do those flood maps really mean? Are you going to have total loss or partial loss? But we will have numbers as close as we can come to that. Yes. All right. Thank you.
So in just a couple of minutes, I'm going to invite all of our speakers, including you, Wade, Ron, and Walt, and Allison, and also Jennifer and Alyssa. And we'll be open to questions and comments from any of you. We do want these to be dialogues. I also, right now, I would like to know what is the next conversation you would like to have, and who would you like to hear from? And we will try to get them. What are the themes, the topics, and the people? Who wants to give some advice? We've heard that you want to hear from the city, so we'll see if we can get Jennifer and her colleagues to come. Yes, go ahead.
I'd like to hear more about the communication of risk to the people of the city of Long Beach. It seems like what they've got, they're tossing in the lap with the 100-year flood zone and the fusion of RCPs and so forth. It seems to be like a lot of people are pretty confused about what they should do or what the risk really is.
So the communication of risk to residents of Long Beach, right? Okay, and it's got to be risk in terms that the general public can understand, I think. All right, yes, go ahead.
I think it's been mentioned a couple of times, but also because of where we are, the state owns a lot of the assets that will be impacted and will possibly fund any mitigation factors. Like, we'd like to hear from the State Lands Commission. So the state really plays a role in a lot of this.
Okay, we'll see. We'll try to get someone here. Any other topic? Yes, go ahead.
I recognize and appreciate the policy point of the city of Long Beach's
So, any idea who you'd like to hear from? The mayor, the city manager, the head of the city council? Well, it's a little hard to get them to come, but, all right, that's a good idea. So that we can explore the political aspects of this, yes. All right, we got it. Any others? Somebody had a, yes, go ahead. We will invite the mayor, the city manager, and also we always invite the city council member in whose district most of this is happening. And we will not only invite them, but we will invite them to make comments. So not just to attend, but to make comments. Right.
I hinted at it earlier, lawyers. I got some great lawyer jokes for you, but there's at least two different flavors of lawyers that I think need to get involved as quickly as possible. One of them are the public interest lawyers, are the people that make their living, public interest law.
Right.
And the others are the ones that are work for private clients, and companies, and some of the kind of trying in the business of protecting, some of the economic generators.
Okay, we've got a good list. Anybody want?
The Coastal Commission is doing a lot of outreach on sea level rise, and it might be a benefit to have those folks in these kinds of conversations, or invite them to town to speak about their perspective on sea level rise in the state.
Okay. Jenny?
I would like to hear from residents about how they've already been impacted by sea level rise and stormwater inundation, showing pictures and footage of what they've already experienced. Because I think that would really drive it home that this is the future, this is present for many residents. And then also get more visualizations about potential solutions. I think if we only talk about future impacts, we're going to get more shutdown and denial just because that's the effective mechanism.
And we're going to hear this afternoon in closed session. We're going to hear from some of them, but that's a very good point. Yes.
Just more a question. If you look, a lot of the places I've been talking to, I hear a lot. I'm reading a lot about climate grief. It's real. It's getting there. Lots of folks are working on our side or starting to feel it too, but I think the public as well. So I don't know if maybe a psychologist or someone that studies that and how to keep us all sane as we go through this process.
Okay. Well, it sounds like we have this could be a very interesting forum, and I think also we might want to time this with Wade with the release of the report from your students. And as was pointed out, all of the people who participate in the program at Cal State Long Beach, these are young professionals, so they're full-time engaged and working on their master's degree. So you're getting good advice. Yes, go ahead.
I also think it's important just to
See, and that's one of the problems of climate change. It kind of sneaks up on you, and I think it is an emergency, but it's unlike most emergencies in terms of how it unfolds, and it has a lot of inertia. So much of the things we need to do today, you won't see the benefits, and they will be revealed in the future from their avoided bad effects. But I don't disagree with you. I'm just telling you, it's hard to get the elected politicians really very interested for the most part. Now, Ed, can I call you were a lawyer and a very good lawyer. What kind of lawyer would you bring in to talk about this? Yeah. So maybe, Alyssa, you could get somebody then from the legal side.
Jerry, just listening to the comments here, I'm wondering, leaving aside lawyers for a second, whether there are examples of other communities in the United States that have dealt with these issues. Florida's underwater. Are there any good examples and lessons from those places, that can help provide, some guidance?
If there are, I'm unaware of them. Now, Santa Cruz, but that's a cliffed coastline, and what we've talked to Gary Griggs and others in the state, what the state really needs is to have some case studies of different kinds of shorelines, low-lying like Long Beach and many other places, and cliffed studies. And there was a report that came out of the legislature late last year talking about the need for these regional and comparative studies. I haven't seen that they put any money into it, but go ahead.
Yeah, well, being a non-scientist, my reaction is it wouldn't be so much what is the scientific difference or the geographical, whatever it is, difference between us and elsewhere. It's how do you deal with political realities of this kind of issue.
Right.
And where do you get the money to solve the problems in a timely fashion short of people standing with their pants rolled up around their knees.
Right. No, very good point. So if you couldn't hear, how do you find out how cities have dealt with these, not from the scientific point of view, but having the conversations and developing plans and moving forward? And that was one of the reasons that we created this project. Alyssa, come on up. Because if you look at what happened in Del Mar or Imperial Beach, there haven't been civil conversations. And so one of the things we've tried to do is to have this series of conversations with different viewpoints so we can all talk to each other and see if we can converge on some lessons. Alyssa?
Absolutely, and maybe right now is a good time to bring up some of the speakers for us to have more of a panel discussion about this. But absolutely, I mean, part of our goal was to bring different voices into this discussion. Obviously, some of the things that were said today was hard for me to hear with the Nature Conservancy, because our approach is. We're really concerned about our coastal resources and what that could mean to lose our beaches, our remaining wetlands in LA County. We don't have that many left. And this used to be a really big wetland system. And we're, when we look at kind of coastal habitats large around the state, we're poised to lose upwards of about 60% of our coastal resources. In Southern California, our beaches are upwards of in the 80%, where we could lose some of our upland beaches. Obviously, in a community like Long Beach, very much a big driver of our economy here, what that could mean. So I think what we're trying to do is have a discussion with the community about what's the vision here. And you know, these are really complex situations, and there's a number of different avenues we need to explore. So with that, do you want to bring up Ron, Walt?
Walt, Jennifer, if you'll come back up, and Giuliano, and also if you'll come back up, please. So let's have a conversation, a discussion. You can ask a question of anyone who's up here, and I think any of the people up here can ask a question of their colleagues. So let's have a good, robust discussion for the next 20 minutes or so. What's for lunch?
So I think we're very lucky here, or you guys are very lucky in Long Beach to have this leadership and having this process going on. But I'd just like to point out to Santa Cruz, I think we're kind of neck and neck there. There's those two reports, the two projects that I mentioned. There's the bluffs that I think are going to be more comprehensive on the economic side, but also the local coastal program update is looking at options for the beaches. And I think that might include some cost benefit, and those are coming up in the summer, so it might worth keeping an eye out for those. I'll make sure to circulate those.
Maybe at that one we'll bring Gary Griggs back also.
Yeah, he's part of the team, so that'll be
Yeah,
great.
I know. All right, who has a first question or comment? Peter, let me bring you the microphone.
I think this is to Jennifer. Wondering what is the city's action currently on, specifically on sea level rise? What are you actually studying, and what are you doing?
Yeah. So my involvement has been helping develop the vulnerability assessment that has been part of the CAP, and that has been studying the flood impacts from sea level rise, from coastal storms, and from riverine flooding. So over the past year and a half, it's been working with a consultant to do the modeling on that to inform what public assets and also private property, how they're going to be impacted, and where the city should be directing its resources to protect critical infrastructure. And really, it's in a stage of learning. We've narrowed down some of the adaptation actions that were initially proposed through the CAP, and are looking for how to prioritize them now, what's feasible in terms of funding, in terms of organization of the community, and really seeing where to go from there. But we're really in a studying and a learning phase. And and then on the mitigation side, it's getting the commitments for carbon footprint reduction.
And one of the things I will say is that one of the things I do with the Nature Conservancy, as well as some of our partners who are closely with the USC Sea Grant program, is to better understand how cities are tackling some of these issues. And I would say actually the city of Long Beach is one of the cities on the forefront of this issue, having held a number of different public forums. But a lot of cities are in this planning phase and starting and figuring out how to learn more about the issue. I know it's hard for folks to hear that because we all jump to solutions. But I just want to make that point that a lot of communities are at the same point up and down the state.
Can anyone think of a city in California, anywhere in the U.S. that really has this situation well under control with their planning? And I can't. Now, it's interesting, Chesapeake Bay that you talked about. You know, Chesapeake Bay, sea level is rising there about twice the global average because the whole lower bay is sinking. And they're losing wetlands, their seawater is going into freshwater intakes. There are serious issues that they have not yet been able to come to grips with.
Yeah, and someone just made the comment, San Francisco. I actually think the West Coast is pretty unique. We definitely have pockets of problems. San Francisco is a really big one. We have multiple airports that could be underwater, lots of critical infrastructure, and the kind of ground center of Silicon Valley. Up and down the California coast, we have pockets of big problems, but we don't have the sort of massive problems that Ron described on the East Coast. And we have a little bit more time because of our topography, because of the way that storms hit us. We have some time to do some smart planning here.
We just don't want to waste that time. What were you going to say?
Well, I don't know enough about the rest of the country, but if I had to make a guess, New York would probably I had a grad student, a master's student that actually works for de Blasio, right, the mayor of New York. And they seem to be at least more appreciative of the problem. Now, again, just looking at Manhattan, for example, it's much higher. There's a much higher elevation. And it's sheltered from the ocean to a large extent, because it's an island. But some of the low-lying areas in Long Island and southern Queens and Brooklyn, some areas of the Bronx, they have very, very similar problems. And of course, they have hurricane, or at least the remnants of hurricane, very high wind, storm surge issues. I know after Sandy, I did Walter and I both, we did some consulting work in New Jersey, the Jersey Shore. And as far as awareness goes, their eyes are this big now after Sandy, because that really drove home the problems that are going to become much, much worse as sea level goes up. And it's going up faster on the East Coast, at least the southeast coast, than it is here. And I think we'll continue to do so because the land is sinking. The whole East Coast is tilting. So I think at least as far as awareness, and New Orleans as well, after Katrina, New Orleans as well, as far as at least awareness. So that's the first step to getting something done is awareness. And that, just to a large extent, that's lacking on the West Coast, at least in the public, I think.
And I think some of you probably know that there was a very large study after Sandy, resilience by design in New York City. And we had one in San Francisco Bay much more recently. The difference between those, though, the New York one, there was money to implement it. So they've been able to implement. In the San Francisco one, there was no money to implement some of those suggestions. Who else has a question or a comment? Yes, go ahead. You.
I would just say Pacifica, California is a good example of really high impacts, but I'm not sure it's a model for what to do, but it's definitely an instructive model. And I had a question to Walt. You mentioned Galveston. We're all, I think, wondering about who's going to pay for whatever we do. Who paid for the entire raising and then raising of an entire community?
I'm not sure, but I know the city was involved. I know the state was involved, and every property owner was involved because they lost all their property. I don't know the details, though. Could I also respond to you raised Pacifica? I've done a lot of work in Pacifica, and people should realize Pacifica is very different, very unique. The entire California coastline, with the exception of Pacifica, has a fairly erosion-resistant lower sea cliff. It's typically about 20 feet tall, and it's because 120,000 years ago, some of the graphs you saw, when sea level was 20 feet higher, the shoreline back then was maybe a mile or two inland. When sea level dropped 120,000 years ago, the more geologically recent terrace deposits mantled the entire area. So along the entire California coast, you see a vertical sea cliff, typically 20 feet tall, and an ascending coastal bluff. The sea cliff ranges from Miocene to Eocene to Cretaceous, typically call it 50 million years old, fairly erosion resistant. Pacifica is unique. The San Andreas Fault has downdropped the landmass about 40 feet. The Franciscan Formation, which is the erosion resistant material along San Francisco, in Pacifica is from minus 30 to minus 40 feet. So what you have in Pacifica are very friable terrace deposits that are very erodible. you've seen in Pacifica as much as 140 feet of erosion in like 15 years. That's because with a little bit of sea level rise and the loss of sediment from the upland watershed, waves have removed what was at one time a very abundant sand source that protected the bluffs. And in the absence of sand, waves reach the bluffs that are unlike any other bluffs in California, and they're eroding as much as 10 feet a year. So Pacifica has some serious problems that are really hard to tackle. But so there's a really good article in the LA Times, but they fail to talk about the geology which overshadows everything else. You need to understand that.
But it's still an important and instructive example of how a community has politically and from a funding standpoint, completely apart from the geology, and I completely agree with you and defer to your expertise, the way they've dealt with it from a political community standpoint, I think has some instructive examples for us. That's all I was saying. I don't presume to speak to the geology of Pacifica.
But just a quick comment on that. I think it's important to acknowledge too that we have more time. We're very lucky here on the West Coast, but we're also ahead of everyone else, really. It's been, and we heard it, someone from the Dutch government, he was a liaison from the Dutchland to the US on flooding affairs, and they said, you know why we're so good at it? Because we tax everything. Everything you do in the Netherlands has a little tax that goes for flood management. And then you can build those gates that look like that, right? But it's like on the Chesapeake Bay, and I was in Maryland talking to some elected officials there, and they're having a hard time to get people on board, even with the science still. And here we have the great modeling, outreach efforts, the visuals. So I think everyone's looking at us to how to do it, but they should get on it real quick.
The challenge then, and I agree with you, we have all of the intellectual horsepower, we have all of the money, over half of the venture capital in the entire United States. We need to figure out how we can harness it to make a difference. And we do have some time, but we shouldn't be screwing around wasting that time.
Agree?
One of the things I was hoping to have a conversation here about was some of the trade-offs that we're talking about. Obviously, Walt and Ron gave presentation on sort of the range of engineering options, and some of those come with trade-offs. And I'm hoping that you guys might be able to address a little bit some of the issues with gray infrastructure in terms of beach loss, in terms of water quality issues, and how do we look at sort of some of those externalities? Either of you.
I don't know what to say for it. That's unusual. Let me turn it around. What was said earlier reminded me of a study I participated in, and one of the agencies, which shocked me actually, it was very surprising, and this started during the Bush administration, the second Bush administration, the military, the United States military. They recognized early on in like they do a 10-year review. It's I can't remember what it's called, but some kind of strategic assessment review. It's not the right word, but they do a 10-year review of what the military threats will be. And about 20 years ago, sea level rise and climate change started to appear in that. Maybe it's twice, maybe it's every 2 years. Whatever it is, 20 years ago, it started to appear in the military. And even during the Bush administration, they were full of climate change deniers. The military pressed ahead with this. And so, if you're looking for an institution, it's not a city, obviously, but it's a big institution with a lot of coastal facilities, as well as a lot of inland facilities that are affected by climate change effects other than sea level rise. But the coastal facilities, Camp Lejeune, for example, did a huge study funded by the ESTCP, whatever it is, some quasi-governmental consortium to fund projects like this. CERDIP was one of them, Strategic Environmental Research and Development Program, that funded a multi-million-dollar study through SPAWAR in San Diego to look at the climate change and especially sea level rise and erosion impacts on Naval Base Coronado and Camp Pendleton. Those are strategically important, obviously very important with application, the study application to all of the other naval and Marine Corps bases, and that was followed up by a study later on that half of it is classified. It's only for DOD personnel, accessible to DOD personnel, but they are so far ahead of the civilian in implementing because they recognize that they can literally die if they don't do this right. I mean, there will be extra casualties, including deaths in combat and in accidents and in climate-related, heat-related, storm-related, transportation-related, flying-related, all of the suite of military activity. So I think that is a good model for how
some of the best
civilians
reports
should
ever
act.
on climate change. And as you say, they started more than a decade ago. And if you look at what they talked about globally in terms of the increase in terrorism and so on, and mass migrations, they were way ahead. And you know, in Norfolk, in Chesapeake Bay, they've probably done the best on climate change in the entire Chesapeake Bay because of the naval base primarily.
Yeah, we're working closely with Navy Base Ventura County at Point Magoo, really low-lying base. And just to give you some insight of some of the conversations we're having, they're looking at strategic retreat, knowing that, you know, at some point they can't fight the sea, and looking at where there are opportunities to consolidate infrastructure. You know, look at the places where they have to have that certain piece of infrastructure in place, and what are the ways to adapt that infrastructure so that it can enable some of the natural processes to continue at that base. But if you know, DoD is looking at how do you strategically relocate, I think other communities should take note.
But you have to also look at the geography, and some of those places, they have space to move. What do we learn from Del Mar? Ron and Walt, you were consultants in Del Mar. What did we learn from not to do what Del Mar did?
Ron, turn this off. Del Mar is an interesting study. Ron and I worked on their Sea Level Rise Technical Advisory Committee, and it was a very heated debate between folks. North Del Mar, North Beach they call it, has about 600 homes, and North Del Mar is very similar to the peninsula here, where the beach berm, using a geology term, where the high ground is, and Ron had a graphic of it, I discussed the same thing, where you have high ground to the west, and then it descends to the east in Del Mar into the lagoon. Del Mar has a similar lagoon, so the elevation of the beach berm in Del Mar is around plus 13. It's NGVD, the old mean sea level, and one block to the east drops to plus 10. A second block to the east, Camino Del Mar, Old Highway 1, is at plus 6. When the Coastal Commission talks about planned retreat, they think in terms of maybe a cliffed shoreline where if you abandon the first row, the cliff just marches landward. But if you abandon the first row of houses in Del Mar, and I would argue the same thing for the peninsula, the plus 13, which has a seawall typically at plus 15, if you remove that first row of houses and that seawall, the next row of houses are at plus 10, and the next row of houses are at plus 6. You can do the math. It does not work.
Well,
So-
my question to that is, you know, a lot of things we talked about in this session today was, you know, what if we restored some of the natural dunes that probably would have been here before we infilled this entire system? That you need some space for some of those
And
natural
we're recommending
approaches,
that,
and
by the
so-
way. We recommended that.
Yeah, and that might mean the first row of houses to have that space for that beach to be a little bit more ambulatory. But
And
curious
that
what your guys'
works.
thoughts are.
That works as long as you maintain the elevation. But you are indeed correct. But that's a commitment to remove typically $5 to $10 million homes. There's about 60 of them. Again, you could do the math. You need to take that and then invest in a dune system that has the protection. Again, go to Florida. Their dunes, vegetated dunes, are 20 feet tall. That's substantially, and again, they're there because of storm surge. Hurricane Sandy would destroy the California coast. It's not physically possible because of our geomorphology, but the reality is that you need more elevation. So I agree with you.
We have a question here.
So for folks in the audience, can you help them understand what the Nature Conservancy is about and what is your mission? And then what is the role of nonprofits, environmental nonprofits, in helping with developing awareness of not just sea level rise, but climate adaptation in your world?
Absolutely. So the Nature Conservancy, we care a lot about our natural environment, but we also work in urban places. We actually have an urban strategy here in Los Angeles that looks at what are the nature-based approaches. You know, what are those strategies where we can have multiple benefits? Certainly, there's been a lot of study on in sort of coastal resilience perspective of the benefits of nature-based solutions. We had a researcher who looked at Hurricane Sandy and some of the impacts there and looked at how wetlands actually prevented somewhere around $650 million of additional protection in that environment. Obviously, we're in a really different position here. And so a lot of what we're trying to do is, well, one, how do we spark a conversation, making sure that the public is aware of some of the risks and participating in the development of solutions. And obviously we really believe in nature-based solutions, that if we restore some of the natural processes that function on our coast, they actually provide a lot of benefit for communities behind them. And so how do we make space in strategic locations to be able to do that on our really urbanized coast? And I think it's a really difficult situation here in Long Beach. We've built and really continue to build up right into our most hazardous areas. But are there places where we could employ some of these things like sand dunes, look at some opportunities for living shorelines, particularly in the near term, but ultimately with a recognition that some of these places, as we get further out in some of the more severe scenarios, that certainly there's going to be some phased retreat. And how do we minimize impact to the community? What are some of the financial tools that might be out there? I mean, this community is, while certainly on the coast is more the upper to middle class population that lives here. But a lot of these people, just like me, a lot of our wealth is in our home. And so how do we ensure that as some of these transitions happen, that it doesn't, that we can have strategies available for people. One of the partnerships, we really focus on what are the big, powerful partnerships to help solve some of these issues. Ron talked about the Department of Defense. We're working really closely with different installations across the state. Another one is FEMA. We just signed a cooperative agreement with FEMA. Someone mentioned, they have a lot of funding that becomes available, particularly post-disaster. But with some new changes at the federal level, a greater amount of funding is going to now be available for mitigation, hazard mitigation, which is different from greenhouse gas reduction, but which really is adaptation. And so how do we make sure some of those funds become available in our communities in California, and that we can make them more resilient and get those really funds working to restore nature to be have that protective value.
And so we're an environmental not-for-profit also, and we see it as our responsibility to raise these issues with the general public, to make them aware. And I think it will be a combination of nature-based solutions and human engineering solutions, because we live in an engineered world, and we're not going to get out of climate change without really relying on technology and engineering. So we embrace this full suite of strategies and try to pick the right combination in all of these. I think you go, Wade, you had your hand up next.
I just wanted to mention from a policy perspective that following Sandy, I think the state of New York offered to buy out people on the beach, and they didn't take it the next step and actually do a takings. And the uptake on that offer was so small, that would have been a great opportunity to rehabilitate the coastline there and help protect nature. So one thing is to make an offer at a market price to buy out your property, but even people that had their homes damaged chose to keep the property, because if you look at it, and the risk is over 50 years, the latter half of the century, the depreciation of their capital asset, their home or whatever, another 30, 50 years they can live there, they may see that as a good investment at this time. So will it take a strategy of condemning and doing a takings?
And I think sometimes we forget that most of this development took place during a period of relatively stable sea level. For about 7,000 years or longer, sea level was really very stable, and that's where most of the coastal development took place around the world, particularly in the United States. And it's only in the last 150 to 200 years that sea level has taken off again. And so you were just a little boy when... Yes, go ahead.
So I just wanted to comment on the community-based organizations. I'm actually sitting here representing not only my parents, who just recently moved off of the peninsula due to their risk of flooding, but also I represent the Conservation Corps of Long Beach. And for those of you, thank you. For those of you that don't know, the Conservation Corps of Long Beach is a 501c3 nonprofit that focuses on workforce development of young adults centered around environmental conservation. So there are 14 certified corps in California, and the purpose of this, that I'm bringing it up, is because we are a tool. Not only are we a tool for operations and maintenance of infrastructure, so those nature-based solutions, bioswales, parks and open space, trails, coastal resiliency as well, wetlands restoration, but we also have a lot of expertise in different areas. So, for example, I'm a lawyer. I know that was brought up. I'm also a certified floodplain manager. So right off of the bat there, we also have a lot of technical expertise as well. So those nature-based solutions, whether it is building sand dunes or whether it is restoring wetlands and riverine habitat. So I just want to point out that there are CBOs out there that are willing to listen, that are willing to actually do the work and commit resources, whether it's funding, whether it's the expertise, or whether it's the actual labor, boots on the ground. We do represent you all. Just FYI, we sit on the LA River Master Plan Steering Committee. We sit on the Lower LA River Revitalization Plan, and we sit on the Lower San Gabriel WASC, which is the Measure W plan that's out right now. So we're out there, we're listening. Please feel free to reach out. We do want your input, and if you know this, if there are other questions, go ahead and talk to us. We actually work closely with Susie Price as well. So we're here to listen. We're here to help as a nonprofit.
Jerry, can we put her on the list?
Yes, will you give us your name and contact information, please?
I think I need to set the record straight. When I was talking about the SAP Act, you have to have a disaster in order to trigger those funds, and that's what happened in Galveston when they actually rebuilt fire. But the state can actually get that money for any disaster that happens. In California, for example, after fires, that's just a glut of money that came in. It's based on a percentage of the damage. They don't have to spend that on fire mitigation. They can actually spend that on mitigating other disasters such as sea level rise. And they've actually come to places like Long Beach and said, we've got money for shovel-ready projects. If you that point, it's actually more of a political problem and discussions between environmental groups and so forth what should occur. It's holding these monies up from being passed on to the person. We will send it our way after we fly.
That's a good point. So again, raising awareness, educating people, both in elected and appointed officials and the general public. I think all of those are important. Who has any other questions or comments? Ed?
I had a question for Walt. Putting aside extending the breakwater, what's the realistic time frame for the planning and permitting for some of the items that you mentioned? Revetments, new sand dunes, for that matter, putting a dam in the bay.
I would say, first off, it's much faster if the city of Long Beach is a strong supporter. I mean, a strong supporter, because every project I do, the Coastal Commission is typically the biggest impediment. You need a strong local community. You need a strong city council, mayor, city manager to go to the Coastal Commission and say, this is what we want to do. This is what we're going to do. So please work with us. With that level of city commitment, and you have a plan that's viable, it could be as little as a couple-year project. I've worked on many projects that are a decade because you don't have the, I'm going to say, the political will of the local agency to push, because as a private property owner, if you want to build a seawall, it's a decade. And Long Beach is worse than most in many ways because you can't build a seawall without demonstrating an emergency. You really don't have an emergency. To build a seawall along the Strand, I think it's a slim chance. But to go with a more proactive, holistic view, you want to do nourishment. You want to, and again, remember, you haven't really done a lot of dredging, brought more sand into the beach. You need that. You have an erosion hotspot, it moves it to the west, the city drags it back to the east. Bring in 1 million cubic yards to build the beach out. If you built it out a couple 100 feet, then you can build, for example, a larger dune field to the south of your homes. That dune field impacts your view, but it also substantially increases your safety. The Coastal Commission likes soft solutions. They like beach nourishment. They love dune fields. They hate structures. Everything I design, they don't like. So as a reality, you need to kind of think about something that's permittable. You need to work with the city. You need the strong city support. But hard structures are really difficult, and hard structures cannot be permitted without a demonstrated emergency. And you're a long ways from having to demonstrate an emergency.
And there are reasons that folks are moving away from seawalls and revetments because of some of the issues with beach loss. And obviously the Coastal Commission is all focused on protecting coastal resources and coastal access, both of which can be a problem when you armor with gray infrastructure up and down the coast. Ron, I was wondering if maybe you could speak to some of the issues here in California with the availability of sediment and sand, and how, unlike the Netherlands that has quite a bit of sediment available to them, we don't have that same luxury here. I was wondering if you could maybe speak a little bit to that.
And this was actually a little bit surprising to me, and it came up in a big way in the project that Walter talked about earlier at Broad Beach. And I think it may come up increasingly in the southern parts of California and San Diego that are poised and have already done 2 beach nourishment projects. Not just the availability of offshore sand to dredge and then bring with ship or pump into the shore, but also, even if sand's available, having whoever the local jurisdiction is and the state actually make that sand available to the entities that want to use it. Now in Broad Beach, I don't know if you know where that is in Malibu. It's north of Point Dume, and there are people like Steven Spielberg that live there, and Mel Gibson, right? Goldie Hawn was in the back of one of the homeowner meetings. Pierce Brosnan was sitting right there. At one of the homeowner meetings, I had the pleasure of explaining coastal processes to Lauren Bacall. It took me a little while to figure out who she was, right? This stunning 85-year-old woman in a black dress with a deep voice. And I finally figured out who that was. So the point I'm trying to make is even those clients have trouble finding enough sand. It's not a matter of money, right? Money is not an impediment at Broad Beach. It's the availability of sand and the permits to get the sand from offshore. And they were talking about another, I can't remember what jurisdiction, but some other area a little bit further south or north, to bring sand in and make it available for their in perpetuity revetment covering to make it look like a vegetated dune, right? Then the storm would come, rip the sand out, and they would, Steven Spielberg would write a small check and put all the sand back, and his neighbors. But even there, it was a problem. So it's not just a physical problem, and we've been studying. There's been studies going back to the 40s or even 50s or 40s at USC started this, University of Southern California, the geologists there, to do the mapping of the offshore sand deposits. So we're pretty good at knowing where the sand deposits that are suitable for beach nourishment are. It's got to be a certain grain size and a certain sand quality. It can't just be any old sand that you would buy at Home Depot, for example, in a bag to put in your kid's sandbox. So we know where those sand deposits are, but it's shockingly limited, and even more shockingly difficult to get permitted, even when money is no object.
Yeah, and the other issue is, because how we've channelized our rivers, naturally how our beaches get sediment is through our river systems, and obviously we've cut off a lot of the natural supply. And so we're gonna have to be very choosy about projects to do in different places because of the lack of enough sediment to do it. And looked like Walt wanted to say something.
Could I also just respond to that? Again, geologically, and to follow up to your point, most of the sand that's offshore, go back 6,000 years, sea level was 400 feet lower. The shoreline at the time was 3 to 4 miles offshore, down off to the edge of the continental plain. In the process of that, every contemporary river has an ancestral river that extended off into 400 feet. As sea level started rising 6,000 years ago, particularly the high energy streams would deposit coarse sediments in these rivers. Surprisingly, most every river it just turns out this way. The river deposit is about 120 feet deep. If you go to the shoreline, right offshore, if you do borings in San Diego County, every riverbed has about 120 feet of a sediment. You need to go past the point of closure to dredge. So there's a sweet spot in every ancestral channel. The best channels are the ones that have high energy stream environments. Like, for example, in Solana Beach in 2001, they dredged some 0.12 millimeter sand when their resident sand was 0.818 millimeter. The next storm just wiped it away. The engineers, not us, said, we learned that we don't want to use the smaller grade size sand. Some of the other sand, they were using 0.35 millimeter. Its coarser grain has a longer residence time. But in order to really mine sand, you need to find old ancestral streams. And like Ron said, a lot of people are doing offshore studies to find and locate them. Then you need to sample to get the materials. But you also need a large dredge that can go out and mine 80, 90, 100-foot water depth to be able to get down and extract the sand. Off of San Diego's Mission Bay, there's probably 10 billion, with a B, cubic yards of sand extending well beyond the depths of current dredge capacities. Great Lakes are building new, larger dredges to be able to mine that deeper sand. And again, the more high energy environments generate a really good coarse quality sand that's really valuable. But you need to kind of explore that. You need to know where look at the mapping that's been done. But there's a lot of sand out there. It's just getting more difficult to get with very specialized equipment.
But as it becomes more and more necessary to have access to it, we have the know-how to do it. It'll be difficult to get permits, but it's not impossible. And I think what we have, with a half a foot to a foot in 2050, we have some time to think our way through the best strategies, and we even have time to get the kinds of permits, because in the Coastal Act it states very clearly that the role of the city is very important, and so if we can get this kind of movement, then we can make it happen.
Yeah, can I comment on that?
Yes.
Yeah, so there's been a lot of talk today about the role of government as there should be. And it made me think that a couple of months ago, we had somebody from the regional government of the Netherlands, because Long Beach has kind of a sister city relationship. And he came to interview various LA region city officials about transition to a sustainable economy. And we asked him about what his impressions were so far. And some of the things that stuck to me were that their economic engines were much more publicly funded. They have more tax funding. The public has more trust in their government. And so, yeah, I think it's just a very, we haven't had like a disaster that has really made us pull the trigger on some of these things. But what the CAP is looking to do on the mitigation and the adaptation side is, to the extent that city government can, we're going out and we're outreaching to help facilitate culture shift around consumption, around, like how we change our emissions outputs and how we think about adaptation. And what really excites me about the Aquarium of the Pacific and the Nature Conservancy is that they've been consistently convening people, and I've been just hearing a lot of really great ideas. There have been people from the Peninsula who have called and said, we should form a financing district because we can to fund some of these solutions. And we've been talking with some students about how to better communicate the urgency of the risk that other cities have already experienced. But for us, we're still kind of fighting to show that climate change is here, and that's a different narrative than exists in other places.
There's another difference between the United States and some of these other countries that came up a few weeks ago when we had a forum here on what to do with the 27 oil platforms off the coast of California. And the people from the UK and from Norway, when they saw the list on the screen of the various state and local agencies that you needed to get a permit from, they said we would never have been able to repurpose or decommission any of the rigs that we have in the North Sea or in the Gulf of Mexico. We thank you. This has been a really good discussion. We're going to follow up, and we'll try to create a forum that includes the people that you have recommended. Thank you all for coming.
Yeah, and we did give you guys all a survey because we're continually learning how to better convene these events, and please write down your ideas of other topics you want to hear about, and we really appreciate your feedback. Thank you to all the speakers. Yeah, for anyone that wants to see the virtual reality, come on up. We have about 5 sets, and you put them on and see it in the VR world.